nothing but.
Hi, heathens. Welcome back. I am here today with the one and only Dr. Aaron Adair. Hello, welcome.
Hello, and thank you for having me here.
Thanks for being here. So for those of you that don't know, I'm sure most of you have guessed this by now. I go down a lot of rabbit holes. You know what I mean? When you have ADHD and it's undiagnosed until you're 33, you just think you're really interested in a bunch of random stuff all of the time. But anyway, I also had a really poor science education growing up. And so as I got older, I became really interested in physics. Still don't know very much about it, but every time I went down a rabbit hole, it had something to do with physics and space and all of these things that I just had no clue about. So I'm really excited to get to talk to a physicist.
We'll have to be careful because instead of going down rabbit holes, we'll be going down wormholes.
Perfect. Even better. Just not a black hole.
Related.
Although I have taken to telling people that they're so dense they're approaching a black hole, which has become my favorite nerdy, insult. In any event, will you please tell the people a little about yourself, sort of what led you down this path of being a physics PhD, what you do now, et cetera, et cetera?
Yeah. So a long time ago in, a pretty local galaxy. And I actually misquoted from the start anyways. But nonetheless, I knew from a pretty young age that I was interested in the sciences. By middle school, I knew my interest was primarily focused in physics and astronomy. I was telling people I was going to be going to college to do astrophysics, and people would just look at me and like, okay, that's a word.
That's a word. That was me. That's a word.
Yeah. Eventually, of course, earned my degrees. So specifically, I did my undergrad at Michigan State and then later my graduate studies at the Ohio State University. Yeah.
Very cool.
A lot of awesome opportunities along the way. Oh, so originally when I started at Ohio State, I was hoping to be interested in astronomy there. And for a while, I was trying to work with some of the people doing astroparticle physics.
Wow.
Later, and actually, basically particles coming from space and seeing what that actually tells us about phenomena going out in the greater universe. So not just dealing with just light from stars, but other sorts of particles, whether it's electrons and protons or especially neutrinos, things like that. And also trying to figure out what is the stuff out there, because there's still the big question about what is most of the mass in the universe, because there's a gigantic question mark in physics about what most of the universe even is. So that stuff there. For a few years, I was also in one of the high energy physics groups, so I got to spend a couple summers at the Large Hadron Collider just outside of Geneva, Switzerland.
This CERN.
Exactly, yes.
I watched a whole documentary on that a while back. I probably understood like 40% of it, but I remember it just being like blowing my mind that these are things that people like, how much we know and how much we don't know. Especially growing up as like a fundamentalist, right? I'm led to believe that like we have the answers to everything. And in reality, we have the answers to nothing. Next to nothing. Anyway. Right. So before we jump into things, I would like you to talk a little bit about the book that you have coming out.
Yeah.
I have been lucky enough to get to read it, but I will let you, since you're the one writing it, tell everybody about it.
Yeah. So it also connects to some of the stuff I had first done when I was still an undergrad. I had the opportunity to spend one summer out in California at the SETI Institute, which is the Search for Extraterrestrial Intelligence. It's basically looking for aliens, but without the tin hats. It's a more scientific, rigorous approach to trying to see both how plausible life is out there and showing with more repeatable, measurable ways of showing this is some sign of intelligence or technology from outside of our solar system. And a way that we can all basically say, hey, if we find this, we are so darn sure that this is from another civilization that we don't have to be speculating about it and just making movies about it. We're going to be doing documentaries about it. So got to use the radio telescope they had in Northern California to scan the sky. I didn't pick up any signals while I was there, but well, I did pick up one signal. Not from aliens. It was there was a film crew from the BBC out there, and they left their cell phones on. So I'm making these measurements, and all of a sudden there's just this crap signal in there from like the 5 minutes they had their cell phone still on.
Oh
they still
use
use that
like,
image.
Really excited for a second?
No. We basically realized, oh, they had their cell phones on. I wonder what it's going to look like when I look at the records. And I look, it's like, nope, this is crap. But they actually still have a poster of my crap data to show people turn off your cell phones when you go there. They still have that, I've been told.
That's funny. Really funny.
So yeah, I already had with my interest in science and actually being part of that sort of scientific approach for looking for that, I had that in my background. But also later in my undergrad years, I started diving into biblical studies. Mostly, independent research on that sort of things, but later, going and actually realizing if I'm going to study this, I probably need to learn the basic languages. So like Greek, Latin, get that under my belt. Because
easy peasy.
The thing that really drew me in was when I was working as a planetarium show presenter. Every Christmas season, they would have this presentation trying to explain the nativity story and the Star of Bethlehem there with completely astronomical means. When I first saw this sort of show, I considered myself at that time a Catholic deist. And so seeing a completely scientific explanation for this just clicked for me. It's like, this is exactly what I think God would do. But then I also realized this wasn't the only theory out there. There had been dozens of theories proposed over centuries. And as I dug into it, especially getting to the original language, I realized most of the people proposing these things can't read Greek for the life of them. They can't even tell the difference between nouns and verbs. And yet they're telling us what the Greek really means.
Yeah, obviously.
Among other things.
Imparted this knowledge to them.
Exactly.
Have you read, I know that you gave a copy of your book to Eric. Have you read his book?
Yes. I've had the opportunity to read his book before I got to meet him at SPL this last season.
Oh, cool. Yeah, he came on and talked about the book a while ago, but the sound was really choppy, so I'm going to have him back so we can talk again. But I was fascinated by sort of his explanations and theories and sort of what's believed about the nativity. Because again, growing up, it's just like you just accept whatever you're told. Like, okay, they followed this star. I don't really know how, but God, so it's fine. But yeah, so after you started learning these languages in undergrad, is that correct?
Yes.
Okay, and then you went on to the Ohio State University.
Yes.
What did you focus your dissertation on? And sort of I guess you can't really balance necessarily, but you continued your sort of Hebrew Bible scholarship, I assume, during this time.
Well, strangely enough, it actually came in use because the area I ended up doing my thesis research in is a field called physics education research. So basically, including, pedagogical research into how we're actually supposed to be convincing people to at least leave this classroom as slightly better conceptual physicists than when they came in. And the thing is, when the students come in and we actually give them a conceptual test, the physics that's in their brain looks like it came right out of Aristotle. And it's not because these students are going in and through high school and reading Aristotle's metaphysics. That's not what's happening. So why is that happening in their head? And it became useful for me when I was doing the literature review for this, not looking just at the physics education research. It's like, well, if these people say this sounds like Aristotle, let me go and check what Aristotle actually said. Right, yeah. And since I could at least access the Greek and see well, what terms does he specifically use for force and motion and things like that, to see if it gives some other clues to see just, is it one concept that's absolutely eternal across all humans, or is Aristotle the weirdo, or are the medieval philosophers the weirdos, things like that. So strangely enough, learning those languages actually helped me write probably one of the very few physics PhDs that actually has Greek words in it that are
very cool.
Not just made up modern versions.
Yeah, no, that's awesome. Farron, thank you for this super sticker. So, was Aristotle the weirdo? Who was the weirdo?
Basically, you only start really getting the weirdos. There's hints of the weirdos that would become modern physics conceptions in antiquity. There's a little bit of writing in the writing of the Dr. Galen from the 2nd century that seems to be getting a little bit closer to the idea of inertia, which is the idea that when an object is thrown, it just continues to move because motion is actually this relative quantity. But that really only starts kicking in and becoming mainstream in minds once you get to people like Galileo, and he gives his various arguments for the idea that actually, motion is this relative thing, and the idea that anything that's moving needs to be pushed is actually faulty. And this is important because you need to have this conceptual change of how force and motion work to make things like heliocentrism make sense. Because right now, standing here on Earth, I don't feel like I'm moving thousands of miles per hour, even though I actually am around the sun at that speed.
That's a big word for Elmo. Can you please define heliocentrism? And also, I thought it was Star Trek?
Yes. Sorry, Captain Deadpool. This is the Enterprise from Star Trek Next Generation. So heliocentrism...
I only know that because I asked him before the show. Sorry.
Yes. So heliocentrism is the system wherein the sun is the center of the solar system and the Earth goes around the sun. All the planets go around the sun because it's the most massive body in the solar system.
Okay.
The most famous version of this coming out from Nicholas Copernicus in the 1500s. And then, of course, that Galileo guy comes along, makes a stink about it, and there's a few stories to be said about that.
Fair enough. So, I talked to you a little bit a while back about this book, This Elegant Universe, which is a popular level sort of physics book, at least as far as I can tell.
It is.
I'm wondering, this is a big question, I know, if you could sort of, what is the focus of, or the thrust, I guess, of physics presently? What are the big questions that people are trying to answer?
In some ways, the big questions now are still the original big questions. What is everything fundamentally made of, and why do things move around the way they do? It's a question of what is stuff, and why does it move around the way that it seems to do? So, among the questions is still, we think we have found, the parts of everything that exists. So, for the longest time, we had the view that everything was made of atoms, and then we discovered that atoms actually have bits, such as the proton, electron, neutron, and then we find there's all these other particles that are a slew of other even more fundamental particles, and we think we might be close to what those most fundamental particles are, but there's still always the question, are we really sure that the quark is, not made of anything smaller, or is the electron possibly have some sort of substrate to it, or is it actually fundamental? It can't be broken down into something smaller. So what are the most fundamental things? And this also relates then to the interactions of those things. And one of the amazing discoveries is that ultimately everything is not little balls of stuff bouncing around, but is actually oscillations of fields. And so all the energy that goes into fundamental physics is related to field theory, especially quantum field theory, one version of which is the stuff that goes into string theory, which is related to the Elegant Universe book.
Yeah.
And so, yeah, in string theory in particular, the idea that you have basically these oscillating membranes or strings that are oscillating in more dimensions than we normally have of space and time, and the difference in those oscillations give rise to all the fundamental properties of the particles that are out there. Is that really the correct theory for how the universe works? Is still an open question. Over time, I've soured on string theory, but I'm probably not going to convince Brian Greene anytime soon to give up his line of research.
So can I ask you then, because again, I feel like woefully underprepared for this interview. Usually I have like some basis for the questions I ask, but I'm just sort of like, I'm an idiot. So if not, so reading this book, he presents string theory or superstring theory as sort of the theory of everything.
Mm-hmm.
And I'm curious, if you're like not a fan of that, what is your sort of hypothesis, I guess, or your theory that you're fond of? I don't know what the right way to say that is.
Yeah, well, I'll explain why I would say I am sour. And when I say sour, I mean I cannot possibly disprove string theory at this point. But
Can anybody?
not easily, at the very least.
Okay.
But the thing that is worth noting, so superstring theory actually depends on a different theory in particle physics called supersymmetry.
Right.
And supersymmetry is something that has been theorized for decades, and in fact, it was one of the major motivations for the construction of the Large Hadron Collider at CERN. The idea that we'll make this gigantic particle accelerator have collisions with so much energy, it'll produce these other amazing massive particles that are only predicted by these theories. And if we can show that, then it shows this other deeper relationship between the particles of force and the particles that make up matter. The problem is we have now been looking for these supersymmetric particles for, let's see, I think CERN has now been running for about, more than a decade now. And while they have discovered a new particle, specifically they did discover the Higgs boson, which was one of the last expected particles in the standard model of particle physics, they haven't discovered anything beyond the standard model, nothing consistent with supersymmetry. And the other problem with supersymmetry is literally every theoretical physicist has their own version. The most simple versions of supersymmetry already were disproved, and they just basically add like other additions on or complications to it. And that would explain, oh, so now the particles we're looking for can't be detected by this machine, but it could be detected by an even bigger machine we could build. And if that machine doesn't find it, then we could say, well, we'll just add more complications to it, so an even bigger machine would be needed to possibly find it. And it goes to the point of, if it's not falsified by these sorts of things, it's at least lowering the probability enough to make us think maybe we should be looking for other options if we can't find any empirical evidence for it. And ultimately, the big motivation for supersymmetry was ultimately, it'd be nice if it were true. That was a lot of it. You actually see physicists make the argument from beauty for pursuing this sort of thing. And they thought it had some value because some of the stuff that happened with the combinations of quantum mechanics and special relativity seemed to make these beautiful equations and combinations and predict new particles such as antimatter. But, as they say, beauty's in the eye of the beholder. And if you look at some of the equations in physics, beauty is not the word that strikes you.
I guess it depends on your definition, like you said.
Yeah.
So Kyle asked here, hold on, if you can define nothing in physics.
Let me start.
Thanks.
So there is definitely going to be some complication here. All right. So if I had a jar and I sucked all of the air out of it, would there be nothing in the jar? Physics says no, because there can still be light in that jar. So you can have photons. So you would have to somehow also remove all sources of light from there. But that's also hard to do because everything gives off light. So you probably have heard of things like infrared cameras. Anything that has any temperature gives off some amount of light. So to make this jar really have nothing in it and no light in it, you would have to bring the jar down to absolute zero, which is a temperature in which there is no motion of the particles. And that's actually something physics tells us we can't do. But even supposing we could do that, because, somehow, wiggly wobbly, timey wimey, we figure out a way of actually getting my 0 Kelvin jar to exist. Would there still be absolutely nothing in the jar? even there, we could still say no, because there would still be the quantum fields, the things that basically define the nature of the forces that exist in space and time. Now, you could call that nothing because there is nothing to bump into, but it is not nothing in the sense that there is nothing that physics is there to explain. And if you want an absolute, complete metaphysical nothing, I think that actually gets into the point of not being coherent. But that gets into other philosophical speculations that, well, there are many philosophers that have definitely talked a lot about nothing with greater sophistication than I can.
Thank you. Yes, thank you for the super chat. So Captain Downpool says, I've heard that the reason there is something rather than nothing is because nothing would be too unstable. Can you elaborate on that?
All right. So the way that I have seen this argument go is that if you actually had a state of absolute nothing, that would also mean that there would be no laws, there's no principles, there is nothing, in a sense, that forces nothing to stay nothing. So it could remain nothing, or it could take any other possible state. And if they're all equally probable, then the only state that keeps you at nothing, that's one state out of an infinite other possible states. And when you take one and divide it by infinity, you get no probability. So you would basically say the reason there'd be something rather than nothing is that nothing has virtually no chance of remaining nothing. That is one way of approaching that. So that would be a nothing wherein there aren't even laws or principles that actually supersede over even nothingness. Because if there are laws, that sounds like something.
I mean, I want to say that makes sense to me. I think on a superficial level, it makes sense to me. Yeah, he said his brain just melted. Same. So this is Ask Professor Jon Snow. I hear he's an expert on nothing. That's a good one. So
I do have to note there was actually an actual Dr. Jon Snow in the 19th century. And in particular, he was the person who figured out the cause of diseases going on at a water pump in London. And basically everyone else thought it was the old style miasma, but he actually figured out, no, it's water contamination. And that doctor was literally Jon Snow. And for the longest time, he had a hard time convincing other people that he'd actually had a better theory of disease, but he basically created like disease mapping and things like that and figuring out disease vectors. He was very foundational in those sorts of ways, but for the longest time, you could have probably gone back to like 1830 and heard somebody say, you know nothing, Jon Snow.
Hey, that's a good fun trivia fact, so now y'all know. We haven't even gotten to the bad physics yet because I feel like I finally have someone I can ask all of my questions to. But we will get there. Recently I forget, NASA or whoever it was. It's like we can see back to the beginning of the universe. Now I have two questions because again, no real science background here. How do we hypothesize how the universe started? I've heard the term like abiogenesis. I just don't know what these things mean. And also then, how is it that we're able to see back in time?
Okay. So I'll start with abiogenesis because that's more of a biology concept and is the origins of life or biology from a prebiotic circumstance. As a physicist, if I want to go back in time, I want to go way further back than that because 4.5 billion years ago, that's nothing. We want to go all the way back to the earliest moments that we can find for the observable universe. So now, how do we know how to look at the beginning and how far back the beginning was? So the first method that people tried was we read it in a book. Like the Bishop Ussher method of counting up the genealogies. Like before that, there really weren't actually even, all that sophisticated of attempts to try to figure out how old the Earth is, other than like Aristotle's argument that it must have lasted forever, but it goes through these conflagrations. So that way it explains why we don't have like infinite technology at this point. Because if we've always been here, where's my flying car? That would be the modern way of putting Aristotle's words in. The modern way of how we have determined what we can about the early universe is a combination of theory and observation. So first in theory, the physics theory that we primarily use to explain space and time is that developed by Einstein, and specifically in general relativity. The theory explains how space and time relate to each other, and also how gravity emerges from that, and the relation between gravity, space, time, matter, all those important things. Now, with that framework, you can start then working out the equations and applying that for the entire universe, and you get a few different possibilities. That you have either a universe, because of gravity, is just going to collapse in on itself, a universe that's stable in size, that something is basically kind of holding in place, or a universe that's expanding out. That those are the sorts of results that naturally pop out just from looking at the equations and applying it at the grandest scale possible. When Einstein first got this, he thought, well, there's no way that the universe is expanding or contracting, because he figured the universe must be eternal in some sense. He's basically kind of convinced with the Aristotelian idea that it makes no sense for the universe to just pop out of nowhere. So he basically, people often say he added a fudge factor to his equation. It's not quite the right way to put it. It's that the most general version of Einstein's general theory of relativity has this term in it, but usually people just say, well, it's just zero. It's just some extra constant from when you do integration, basically. But he said, okay, we'll keep that constant in, and we'll give it this value, and just the right value to keep the universe eternally static. And then an astronomer in particular by the name of Edwin Hubble is able to use a telescope and actually figure out a few important things. So one is that he used this kind of star called a Cepheid variable. It's the star that kind of oscillates in brightness. And we can actually use those oscillations to figure out what its actual brightness is. And if you know the actual brightness of the star and you measure its brightness with your telescope, you realize how far away it has to be. So he first figures out how far away these stars are and the galaxies they're in, and realize, hey, that thing that we've been calling the Andromeda Cloud or the Andromeda Nebula, that's actually a galaxy that is about couple million light years away. It's the term at that time was a island universe, because they're just so separated out from each other. They're basically completely other pieces of space. But then he also starts using these measurements and says, okay, if I look at this galaxy, I see that it's moving away from us with a certain rate. And if I look at a galaxy further away, it's also moving away from us at a faster rate. And actually saw there's this linear relationship between the distance to the galaxy and how fast it's rushing away. And you realize the only way that makes sense is that the entire universe is expanding. Eventually, Einstein sees this and he's like, okay, I screwed up. The universe is actually expanding. And if the universe is expanding, well, run the clock backwards. That means earlier the universe was smaller and smaller, and you can run the clock back and realize on that observation, the universe basically had some sort of starting size of zero, or near zero at least.
This makes my brain hurt. I understand, basically. I think one day I was thinking about, I don't remember why, it must have been around the time when the most recent images from that telescope came out. Thinking about the universe constantly expanding. And I remember asking, like, okay, well, what is it expanding into? Yeah. Right? Like, and a lot of people tried to make that make sense for me. And while I get what they're saying, I also don't. Because I'm like, how do you expand into nothing? But I think I'm just scientifically illiterate, so that's fine.
Well, I think it's a limitation of the analogy, and I actually tried coming up with a slightly better analogy, and in particular, I think it'll work well for you because of your economics background. I think you should see the expansion of the universe in the same way as inflation works for money, that you need more dollars to have the same thing. With the expansion of space, it's basically saying you get in a rocket ship and you need to pay more time to get to your destination.
Okay, that actually makes a lot more sense. That makes a lot more sense. Okay, thank you. Anything with a non-zero probability given unlimited time will happen. Is this correct? I believe, doesn't that have something to do with the law of large numbers, perhaps?
Yeah, if something has like, a 1 in a billion chance, well, given a billion opportunities, you'd expect it to pop up once, and given an infinite number of opportunities, anything that is non-zero will show up eventually. That's the basic mathematical consequence, and in the other form of it, infinite monkeys on infinite typewriters will eventually type out Shakespeare.
Fair enough. All right, thank you for the super chat. Wouldn't time dilation caused by the denser state of the universe as we go, quote, back in time, make the universe progressively, quote, older as we do so, in the sense of making the past less, quote, accessible to us?
So with the greater density of the universe back there, it actually doesn't increase time dilation. That time dilation is actually an effect you only get between different observers in the universe. But if we're talking about the universe in general, you won't have that sort of issue. The time dilation, which is something that comes up in special relativity, wherein if two observers are moving relative to each other, they actually will not agree on the length of time measured by their clocks.
That is actually, reading about that was kind of bonkers to me. Like this idea that you could use, two people could use the same watch to measure something and it would not be the same.
Yeah.
Wild. Anyway, sorry. I don't know if you had anything else you wanted to say about that.
I mean, that's the main thing, that basically time dilation doesn't come into play when you're dealing with the entirety of the cosmos at once. So we fortunately don't have to add that complication on top of everything else that's already complicated enough when it comes with general relativity.
Fair enough. Can you explain, and this is just my question, what antimatter is and what dark matter is?
Antimatter, yes. Dark matter will be harder because that is an active area of research. But
Okay.
antimatter, okay, but antimatter in some ways is the same as regular matter. That if you looked at it, it has all of the same characteristics as regular matter, except that it has opposite charges. So basically, you learn that the proton is a positively charged object, the electron is negatively charged, and that's it. With antimatter, instead, the proton has a negative charge, and the electron has a positive charge. So also they call the antimatter version of the electron the positron because of its positive charge. Now, this sounds like a pretty trivial thing, but the other thing that happens is that when you have matter and its antimatter counterpart and you bring them together, they interact and turn back into pure energy. And conversely, if you have enough energy from E equals mc squared, enough energy becomes matter, what actually pops out is a particle and its antiparticle.
All right.
Yeah, that's the basics of that there. There are also additional kinds of antimatter particles that are less common that also show up in things like nuclear decay. So in radioactive decays, that you'll have the nucleus of an atom breaking apart into smaller chunks, but also in that process of those changes, it also tends to give out another extremely low mass particle known as a neutrino. And depending on the process, it could actually be an antineutrino, the antimatter version of the neutrino. Now, the other part was you said about dark matter. So what dark matter is supposed to do, we can explain that. What dark matter is an active area of research. But the basic thing is this. Back in the mid-late 20th century, a number of different astronomers were noticing a problem with the galaxy that we live in, the Milky Way galaxy. And the basic thing is we can see that the entire galaxy is basically spinning. And it's spinning around its central point. But if it's spinning around, what's holding that thing together in its shape? Well, it must be gravity. And this gives then predictions for how fast the stars must be going at the outer edges versus the midpoint versus very close to the center of the Milky Way galaxy. You would have an expectation of what is the velocity of those stars. And the problem was when looking at those stars and measuring their speeds, we realized most of them were going way too fast, as if there was a more gravitational force holding them in place to let them go and spin around really fast and do so. To give it a bit of an analogy, if you take like a ball on a string and start swinging around, you can feel the force of that ball as it's spinning around. And if you try to spin the ball around faster, you can feel you have to provide more force in the string to actually keep it going around faster and faster. So if the stars are going faster than expected, then there must be an even stronger force doing that. But if we look and see what's all the matter in the galaxy, and we see that that's not enough to explain it, we now have to explain it with mass that isn't there. And we give it the name dark matter because it's matter we cannot see. What is the dark matter is the part that's debated. Many people wondered maybe it's just planets or dead stars or black holes. It's just the sort of stuff that's kind of like the detritus of all the other junk just floating around that just doesn't shine enough for our telescopes to notice. That is the less popular view these days based on observations. The most common version of dark matter is the idea that it is some kind of yet undetected particle.
Okay.
And it's also then one of the motivations that people have when they come up with their different versions of supersymmetry. They'll also try to have and say, and it predicts this particle, and this particle could also be a good dark matter candidate. So they'll also try to say, oh, you could detect it at, say, the Large Hadron Collider, or maybe we can detect it out in space. Try to find other ways of saying, why I should get the Nobel Prize ultimately.
Fair enough. Okay. I don't remember the names of these things. I remember hearing about certain particles that behave differently when you're looking at them and than when you're not looking at them. Does that sound like anything?
I think what you're describing there is what is related to what is often called particle wave duality. When you are doing experiments with light or with particles and you're either looking to see like which apparatus it's going through, or if you don't, it actually changes the result. The quintessential version of this is called the double slit experiment. And as the name suggests, you have just these two very thin slits that will allow either light or particles you're shooting through. Light's probably the easiest. Well, what would be the easiest? It's a little bit hard to say which will be the easiest because we've actually discovered that all particles actually have wave-like properties, but I'll just stick with light for now because we've known light has been a wave for over 2 centuries. So imagine you're basically firing light through these tiny little slits. If the light goes through both slits, the light will then, because it's a wave, interfere with each other. So sometimes the crest of one wave of light and the crest of another wave of light will line up and you'll get an even bigger wave. So you'll get bright light. But if you have a crest and a trough meet, they'll cancel out and you'll get darkness. And this will produce a known pattern on the back of a screen that sees the light going through that double slit. Now, the idea, though, is, okay, light is a wave. This is what we would expect to see. But we've also learned that light has particle-like properties, that actually it comes in little packets. So what if we just fired not a lot of light, but just one photon at a time, one particle at a time? And so it has to go either through the left slit or the right slit. It doesn't have anything else to interact with. It can't actually do that sort of wave interaction. You can't have crests and troughs meeting with each other. And now I'm hitting my microphone.
I talk with my hands when I'm excited, so I get it.
Oh, yeah. Okay. So we do this experiment, and we've done this with light, we've done this with electrons, we've done this with very large molecules. And the really weird thing that happens is even if you fire the particles one at a time, and you look at the pattern on the back of the screen, it's still a wave interference pattern. It's almost somehow the particle went through both slits at once to slap itself to have wave-like interactions. Now, you're thinking to yourself, well, that sounds like absolute crazy. It needs to go either through the left slit or the right slit. It can't possibly go through both. So you set up an apparatus to look to see which slit does it actually go through. But when you do that, you don't get the wave interference pattern from the double slit. Instead, you just get these two bright spots as if the particle just went straight through. So looking at it made it behave like a particle just shooting straight through, or at least a very small wavelength light just shooting through. And if you don't look at it, even shooting one particle at a time, it gives you wave-like interactions. And this has been central to the arguments about what is the nature of waves, the nature of particles, the nature ultimately that is described by quantum mechanics, because this thing called the double slit experiment is basically the crucible where all theory has to go through to see what makes sense.
This sounds like magic.
I've done the experiment
really.
myself to see it as well, so it's completely reproducible. And like I say, you can do it with light. It can be done with electrons. The largest molecule that I know we've done it with is something called Buckminster balls. These are molecules of 60 carbon atoms, and they look like little soccer balls.
Okay.
And they're called Buckminster Fuller balls because if you've ever seen these bits of architecture from Buckminster Fuller, he was really big into geodesic domes like the Epcot dome. Mm-hmm. It was like, hey, this basically looked like his Epcot domes. Okay, those are molecules. Let's fire these molecules through the double slit. And what sort of patterns do we see? Oh, we also see wave-like interactions. Oh, we still get all the weirdness of quantum mechanics when we do and don't look to see which slit the buckyballs fly through.
That's wild. That is wild. So I didn't actually mean it sounded like magic. It's just like, it wrecks my brain to try and think about how that's possible.
I will point out, though, many people have not only the reaction that sounds magical, they actually think it justifies magic itself. You literally have Deepak Chopra saying, because quantum mechanics, yada, 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 your mind makes the universe, yada, 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 I will live forever.
Oh, well, I don't want to live forever, so I hope it's not magic. Okay, there was a question. Let me see here. The particle antiparticle from void energy. That's how Hawking radiation works? Question mark. How does the antiparticle matter? How does the AM always / more often fall into the black hole?
AM, I think, for antimatter.
Antimatter. Okay, sorry.
Okay. So what's going on here? So in particular, he or she, I don't know the... Well, the icon is brain, so I'm going to say he.
Is a he.
Yeah.
I believe.
Well, I'm just going to go by the icon that it's the mouse brain. Hawking radiation, it goes back to Stephen Hawking.
I feel like you're the brain and I'm Pinky.
I don't have the voice to be the brain. I do not sound anywhere near and deep as register as him. I sound much closer to Pinky. North. Okay. Now, so Hawking radiation, this was an idea that comes from the late, great Stephen Hawking. And he basically is able to show that black holes can actually let go of some of their mass at a very slow rate. Now, in his book, A Brief History of Time, he tries explaining it with the idea of particles popping in and out of existence right at the what's called the event horizon, the edge of where we basically say anything that's within this region is stuck within the black hole forever, and anything outside of it has at least a chance of escaping. Maybe not much of a chance, but some.
Some.
So the idea that he presents there is that one of the things we actually know is that in empty space, you actually have the quantum fields fluctuating around and seemingly have particles popping out of nothing momentarily. On very short time scales, you can have apparently matter coming out of nowhere so long as it annihilates itself very quickly. So it averages out so there's nothing overall. So the way Hawking tries describing it there is that perhaps these particles are forming right at the edge of the event horizon. So a little bit pops out beyond the event horizon and a little bit still stays in, which means the black hole loses a tiny bit of mass, and this can then become that form of Hawking radiation. So two things to note. One is that it wouldn't always be matter or antimatter that escapes. It should be equal amount. So Zierke, it would be the case that both could be possible, but it's also the case that Hawking's popularization of the explanation isn't honestly that great. There were much more complicated ways that he actually was able to derive the idea of Hawking radiation. Was that related to radiation? I forget exactly, but it's like some weird like boundary condition between like the early universe and the black hole event horizon itself, and basically having harmonics between the black hole event horizon and the early universe. I forget the exact details. It was a really strange way of approaching it, but it was something that he was building on with previous theoretical research and showing one of the consequences is that the black hole will have these extra modes of radiation to explain itself.
Big Zebra said Unruh? Unruh?
Yeah.
I don't know.
I think that's, or is that a separate thing? No, I think Unruh is different. Unruh radiation is another effect where accelerating bodies can also give off radiation. There are so many different kinds of radiation. It's surprised that we haven't all mutated.
Fair enough.
Yeah. I would just basically say Hawking's original explanation was probably too much of a simplification, and it also depends on a very realistic interpretation of what are called virtual particles. That when I say like empty space has particles popping in and out of existence momentarily, that is one interpretation of how you can look at the quantum fields, but in quantum chromodynamics, there are other ways of describing the same thing without these virtual particles. So it's a kind of a weak analogy based on an interpretation of virtual particles that doesn't seem to hold up to scrutiny. So yes, I am coming after Stephen Hawking. What's he going to do about it?
Nothing. So quite literally nothing. R.I.P. though. Good buddy. I had a question and then I forgot it. Okay, so we're 45 minutes in, and this has been fascinating, and I feel like I could probably just ask infinite number of questions because I don't know anything. Um, but I do want to touch on bad physics because
Okay.
that's what this is called, right? And if anybody has other questions, feel free to super chat them or tag me, um, and we'll circle back. But for now, I think it might be useful to discuss some of these bad physics that you had rattling around.
Yeah. I kind of have in my head a couple different categories of what we might call bad physics. The bad physics where it's just complete, utter nonsense that, like, you're not even trying to do actual science. You're making things up for your own reasons, or you just have whatever pet explanation you want, and you don't care if it breaks any other laws of physics along the way. You just want to get to that conclusion. Or you are applying the laws of physics as we know them, but with very bad starting premises to things that are going on. So, an example of the former that I probably see the most is, well, the most recently I've had a more interaction with people that propose something called the electric universe. Uh, if you haven't heard of that, it actually goes back to a psychologist by the name of Immanuel Velikovsky, who basically, among other things, tries to say gravity is not real and everything can be explained with electricity and magnetism. And he also uses this to explain the strange stories from the Bible as Jupiter spat out this giant comet that shot around the inner solar system that caused terrible things to rain down the sky for the plagues of Egypt, to cause the Earth to stop spinning when Joshua made the command, and all these sorts of things, and that this comet finally settled down and became the planet Venus. This was one of his early proposals, and if this sounds like something very hard to explain by basic physics, you'd be correct. So among the things he has to do is come up with his own physics, and there are.
I mean, it sounds very hard to explain. Period. Like, even as someone who doesn't know much physics, it just sounds very hard to explain.
Yeah. And he's even like, when he pressed on it, saying like, yeah, my ideas actually break very basic things like conservation of energy and momentum, which are considered like bedrock things in physics. If you're saying you have something that doesn't conform to conservation of energy, that's basically saying you can lift yourself up by your own bootstraps. And you say that without being a Republican.
Without being a Republican.
Yeah, the sort of nonsense that literally you can sit inside your car and push the dashboard and make it go. That's the sort of nonsense that happens if you deny things like conservation of momentum. But Velikovsky's just like, well, that's how it is. It's like, no, that's not how it is.
Yeah, no.
But there are people who still kind of push his idea of we can explain most things in the universe not in terms of gravity, but in terms of electricity and magnetism. And among the things that also saying like, well, actually, all that stuff about the Big Bang is nonsense. Stars don't actually fuse hydrogen into helium, and that's not why they glow. It's basically the sun is a giant electric circuit. You may not happen to see the giant currents going into and out of the sun, but it's there, really, we swear. And that's why the sun actually lights up. And all sorts of other things. And, you know, I've gone on a couple other platforms to explain why that's nonsense. I did a bit of a deep dive actually on Gnostic Informant to show, like, first off, we know gravity exists. We can measure it, like, here on Earth, nice and easy. Two, you definitely can't explain it all with just electromagnetism. There's just absolutely basic things you can do in your kitchen to show that that is not true, let alone on a planetary or cosmic scale. And yeah, the biggest people who are pushing electric universe stuff today, none of them actually have physics degrees. Cool. And those who are trying to say how the sun actually works, they might have an electrical engineering background. But, well,
I can make stuff up too.
Yeah. Yeah. And I mean, there are just, you know, basic observations we can do to show that these things are wrong, and they just have to deny all the way through.
Sounds right. I think actually the sun is made out of inflation. I don't know. Seems right.
It might have some inflatons in there. Yeah.
Okay. So because I don't know physics, I didn't have anything to ask about bad physics. However, I am very curious, after having read most of your book, not all of it. What is the likelihood, and how can we know, or how can we at least sort of safely guess or assume what the likelihood of extraterrestrial life is?
Oh yeah, oh yeah. So that is, of course, such a grand question in the sciences today. Are we actually alone? And yeah, depending on which scientist you talk to, you'll have enthusiasm for the idea that there is just an entire federation of civilizations in the Milky Way right now, all waiting for us to get our act together so we can actually finally join the club. And others who will say we are completely alone in the entire universe. And well, that's a pretty wide gulf. So how do I
Both are
correctly
terrifying.
answer that? Yes, that is true as well. That is exactly what Arthur C. Clarke said. Both options are absolutely terrifying. So in the book, which hopefully will be available come early April, that is the plan. The book Aliens and Religion, Where Two Worlds Collide. I forget the entire second subtitle because my memory is not good enough.
Please hold. No, go ahead. I'll pull it up.
But the approach we take is what has been kind of a classical one, where we use something called the Drake equation. This was a combination of factors put together by the radio astronomer Frank Drake in the early 1960s. I've only had one chance to meet Drake before he died last year, unfortunately. From what I could tell, absolutely great guy. The little interaction I had with him, I just felt nothing but warmth and happiness from him. But the idea is that basically you have these various factors that should relate to a reasonable guesstimate of how many civilizations would be currently here in the Milky Way galaxy. So things like what's the rate of star formation, how many of those stars have planets, what fraction of those planets are actually potential places for life to emerge, what fraction of those planets actually do have life, what fraction of those life-bearing planets actually become intelligent and intelligent in a way that we would recognize it, what fraction of those intelligent civilizations actually then produce a technology that is detectable, especially in terms of like radio waves. And then lastly, how long do they stick around? Because if they're only around for 5 minutes, we're probably going to have a hard chance being around in the galaxy at the same time they are. If their 15 minutes of fame is a literal 15 minutes, it might not line up with ours. So the problem is some of the factors in the Drake equation we can know reasonably well. When Frank first wrote the equation down on a chalkboard, we did not know if other stars even had planets. We had never even detected those. That was just hypothesis. And we only really confirmed the existence of what are called exoplanets starting in the 80s and really in the 90s and 2000s, and really showing, pretty much every single star seems to have planets. So, we have been able to advance in this, but there are still factors in there that we have no good clue about. And in particular, what fraction of life-bearing worlds actually develop intelligence. Since we only have one world that we know with life on it, our sample size is what we would call pathetic.
N equals pathetic.
I think I've seen that in one math equation.
So the subtitle is Assessing the Impact of Discovering Extraterrestrial Life on Religion and Theology.
Yes. It fortunately does not roll off my tongue well. I might need a little bit more liquid courage.
Please. Okay,
But,
so also just...
Yeah. Oh, go ahead.
Just a reminder to everyone in the chat, if you have questions, either super chat or tag me. I'm happy to ask them. They don't necessarily have to be about the book. They can be about whatever. You have access to a great mind. Not mine, but somebody, Aaron. Dr. Aaron.
And you might want to ask it quickly because the quote-unquote great mind that you mentioned might start slipping. Okay. So,
go ahead.
but the number of those factors in there are extremely speculative. Perhaps one of the most speculative you might first think is, what's the lifespan of such a civilization that's actually intelligent and communicative that we could actually detect?
How do we even estimate that?
Yeah, exactly. Because, the best you could say is, well, we're an example of that, and we have been a communicative civilization in terms of radio technology for about a century. So you might say, well, it's at least a century based on this sample. But again, that's pretty limited. And how long are we actually going to be around? Are we going to be gone in 5 minutes because Putin finally decides to start hitting the button? Or are we going to be around for millions of years or to the end of the universe, which is wonderful but optimistic and not based on data?
Right. Yeah.
So, there's very few ways that we can, in a data-informed way, but there are some interesting approaches that have come up to try to actually say, based on just our lifespan of a communicative civilization, what is the average lifespan of that? And the argument that is used for this is called the Doomsday Argument. And I hate the name for one
I was gonna
simple
say, it sounds
reason.
really uplifting.
Yeah, it's definitely well. The thing is, it's definitely not an uplifting name, but it's also a terrible name because this is the only doomsday clock that actually ticks up, not ticks down. Because the interesting thing is the way that it's actually used to say if we are just like a random sample from possible civilizations, we're more likely to be in the middle of such a distribution. So we would say, well, we've been around this far here, and so assuming an exponential decay of how long civilizations stick around, then you could do a little bit of math to figure out what's the average lifespan of such a civilization based on us being a random sample from that. And then you would say, okay, then the average lifespan of civilization, it works out to something like 3 centuries. But the interesting thing is, the longer we stick around, the longer that time frame that we put into the equation, so the longer the average civilization is. So, like I say, it's a doomsday clock that ticks up. It's not like the one from the group of concerned scientists. I forget their full name right now.
Get closer to midnight or whatever.
Exactly. Yeah.
I love seeing that because it's like, okay. So I had a quick question. You talked about like, if we are around to the end of the universe. Now, I don't think there's any possibility of that given how terribly we treat the planet. But my question mostly is like, what do physicists sort of think about the end of the universe, right? Like, do they have any thoughts on how far away it is or what will happen or why or what, like do they have any theories on it?
Yeah, but they're not going to make you happy.
It's okay. I'm already not happy. I'm mentally ill, so it's fine.
Okay. Well, so the primary thing is the reason we can see stars in the sky is because they are undergoing atomic fusion.
Okay.
And because they have to use hydrogen for their fuel, and after hydrogen, they can start using some other elements, but they won't last as long. We can already basically realize stars have a finite lifespan. They will use up their fuel and eventually not have enough to continue the fusion process and eventually die out. Now, new stars are forming, but at a slower and slower rate because there's just less and less material. And as far as we can tell, there is not a giant entity shoveling a new material into the universe. So once we have basically run out of that, the stars are going to be slowly dying off. Moreover, because the universe is not only expanding, but expanding at an accelerating rate, the most distant galaxies are racing away from us and eventually will be so far away from us and going at such speeds that they will literally be moving away from us faster than the speed of light. And this is actually possible within general relativity. That if the distance is great enough, and because the distance that this velocity is based on how far away they are, if they're far enough away, eventually that speed is beyond light speed, which means you won't be able to see them anymore.
Okay.
The galaxies that are far enough away, not only will their stars be dying, but they will have gone over the cosmic horizon and become invisible to us forever.
Wow.
And now, even that is not the full end, because as was mentioned earlier, black holes also do give off a tiny bit of radiation, which means eventually they too can run out of stuff to radiate. Now, the time scans of this are just phenomenal. So the time that you'd have to wait for the death of all stars in the universe is on the order of trillions of years. There's also the open question in particle physics if protons actually have a lifespan or if they are immortal. If they have a lifespan, then they might also begin to start just decaying and breaking apart. And in 10 to the 50th years, maybe most of the protons in the universe are gone. But even then, the black holes will still be around, or at least the most massive ones. But even after 10 to the 100th power, or a Google years, and 10 to the 100th power, that's a 1 with 100 zeros after it, even the black holes will die.
Wow. And
then at that point, the universe will have nothing moving around. The entire universe will be so close to absolute zero. Everything will basically be still. In a sense, time will stop because nothing will noticeably change anywhere.
So does that mean that, the Earth would just go dark? Does it mean we'd be sucked into something? What is it?
Fortunately, the Earth won't be around for any of that. So,
good.
So the time span for just the Earth, just the local neighborhood, in about 1 billion years, Earth will probably not be habitable because the sun is slowly getting larger and brighter, which means it's going to produce more and more
like my
energy
personality.
for the sun, for the Earth to warm up, and at a certain point, it's going to actually pretty much kill the carbon cycle on Earth. And then after some time, it becomes so warm that even all the oceans will boil off, and so life will be impossible on
Okay.
Earth. And that's in only 1 billion years. After about 5 billion years from now, the sun will actually go into another phase of fusion and start to blow up so large that the outer atmosphere of the sun will swallow Mercury, Venus, Earth, and possibly Mars.
What did they
And
ever do
so
to us? Dude.
they were in the same neighborhood. They failed to move out. Homeowners
I mean,
association issues.
we gentrified this place, I think. So it's just poor planets. Actually, I have probably a basic question I just don't know the answer to. What is the oldest planet?
Ooh. So, in our solar system, at least, all the planets
Right.
formed at about the same time. So it's not really possible, probably, to say one is older than the other per se, or at least not noticeably much. Though Earth's formation also got a bit complicated because relatively early in the formation of the solar system, the early solar system was still very chaotic, and so lots of stuff bumping into each other. So rocks are falling from the sky onto the basically molten Earth for millions of years, but those are all pathetic tiny collisions. It's like just some 20-kilometer asteroid. That's nothing. The real kicker came from an object that is known as Theia. That's the name given for this object, and it was about the size of Mars, and it collided with Earth 4-ish billion years ago. And this collision is the probable cause of the formation of the moon.
What?
So basically, you got yourself.
Say more. Say more,
okay.
please.
So among the realizations that happened thanks to the Apollo missions to the moon, and they could bring back rock samples, we realized the moon is basically mostly Earth stuff. So it's like, okay, so it looks like, the moon has come from Earth material, but how do you get stuff on Earth and throw it up into orbit, especially something so large as our moon? And by comparison, our moon, compared to the size of the Earth, is extremely large. Mercury has no moons at all. Venus has no moons at all. Mars's 2 moons are basically captured asteroids. They're tiny, pathetic little things. Most of the moons around Jupiter are tiny compared to Earth's moon, and Jupiter is gargantuan compared to the Earth. So how does Jupiter have relatively small moons compared to Earth with this moon that is like a sixth, or what is it, a sixth, fourth, the size of the Earth itself is just grand in size. So
Wait, the moon is a sixth the size of Earth?
I'm trying to remember the exact ratio right now. I remember the gravity is about 1/6, but then I have to remember the radius, so I'd have to triple check
That's
what
okay.
the mass is. Yeah.
Even if it's 1/6 or if it's 1/8, doesn't really matter. That's huge.
Well, the thing is, if I'm wrong about that, I'm going to kick myself. So.
Oh, okay. Well, don't let me
Okay.
stop you.
Okay. But nonetheless, the moon is a significant fraction the size of the Earth, so that is unusual. So like the main contender for what most likely happened, and this based on a combination of evidence from moon rocks and from simulations, is that relatively early in the formation of the Earth, while the Earth was still basically hot, relatively molten, and there were still other large chunks of stuff going around the solar system that would form the other planets, one of these other objects orbiting the sun is called Theia. And it is about, oh, thank you, Jimmy, quarter the width. So that's that big. That big.
That big.
Yes. that is the most English way to put it, yes. So you have this object Theia about the size of Mars orbiting the sun, but in an orbit that is going to eventually have it collide with the Earth. And one day, basically, Theia finally comes close enough and makes this not directly straight on, but glancing blow, and just, shatters the side of the Earth and shoots a huge amount of material into orbit. But also in that process, it loses a lot of the kinetic energy that the object had. So it loses the energy and keeps it forced to be in orbit around the Earth. That material then from gravity forms back together and becomes our moon. And we've been partners ever since.
The moon is our bestie. God, I find it mind-blowing that all of these things came together so that we have like a habitable planet, and like Yeah, I don't know.
Yeah.
It's just wild to me to think about all of this.
Oh yeah, that in fact that is usually one of the arguments as well when it comes to finding extraterrestrial intelligence or ETIs. The question is, well, how common is life? Is it the case that the conditions have to be absolutely perfect, and the dice just happen to finally roll right for Earth, and ultimately it rolled well for Earth because there are just so many planets in the universe that it had to happen eventually somewhere, and maybe we truly are alone just because it's such a rare combination? Or is it the case that life will, as Ian Malkin put it, find a way? That is still debatable, but there are plenty of astronomers and geologists who will argue that the combinations that made life possible is a rare combination. There's actually a book from, I think, about 2000 called Rare Earth, and proposes what's called the Rare Earth hypothesis, that there's all these factors that are just absolutely required for life to emerge and become complicated enough to eventually lead to primates that can not just hit each other with sticks over the head, but eventually use them as tools to build rocket ships.
Yeah. Yeah. Something that I've always, so again, I have no real background in science, but like every time I hear physics brought up at a popular level, there's always discussion of like dimensions and potential alternate universes and like all of these things, right? And I'm just curious, like what people actually in the field, I know dimensions are like, obviously there are dimensions, but like, yeah, I'm just curious about your thoughts on that. I'm curious about wormholes. I'm curious about people that think you can time travel. And also, sorry, this, you mentioned this in your book. So I do want to talk about that. But first, this is bad physics. I want to talk about wormholes and time travel.
All right.
Or just whatever.
All right. Well, in some ways, time travel is both easy and impossible. Easy in the sense that we're doing it right now. We're all traveling forward in time. The hard part is trying to go backwards in time. That's where all the fuss is about. And ideas of traveling back in time are, centuries old. I think there were a few good time travel stories even before H.G. Wells's novel, but the issue that will always come up are the paradoxes. And the most famous version of that is the grandfather paradox, where the idea that, okay, imagine you could travel back in time and in such a way that you could actually affect the past. So what if you went back in time, found your grandfather, and killed him before he gave birth to your father? In which case, you would never exist. But if you never existed, then you've never gone back in time to kill your grandfather, which means your grandfather, carried on just fine because you were never there. And now you do exist, you don't exist, you do exist, you don't exist.
Eternal
paradox.
Loop.
Exactly. Right, yeah. So how do we avoid these sorts of paradoxes or just straight up contradictions that seem to make it impossible? There's, a few possibilities. One is it's just impossible to travel back in time. What happened in the past stays in the past. It is just not possible to change that. And it is the best way to avoid the paradox is just make it so it can never even come up in the first place. Now, that obviously isn't very good for an episode of Doctor Who.
Sure. But then that's assuming, right, and maybe I'm wrong here, that time is this sort of linear thing that you can only move sort of one way on.
Yeah. Well, like I say, the only issue, the question is, can you move backwards in time in a way that is consistent? Which then leads to the option, you are able to go back in time, but you have to make sure that whatever you do in the past leads to you having gone back in time in the first place.
Right, yeah.
So,
yeah.
In a sense, you have to have a set of billiard balls that have to bounce around in just the right way that it comes back around and hits the initial billiard ball to pump in the first way. Okay. But even that can lead to paradoxes, which are usually sometimes called the bootstrap paradox. So here is a possibility that you can imagine, and I'm literally taking this from an episode of Doctor Who.
Mystery Science Theater.
Slightly different. Are you a fan of Beethoven?
I mean, I think he was very talented. I don't listen to his, concertos on the daily, but yeah, he's good.
Okay. The example of Beethoven came up in particular because in some of his, great things, his symphonies in particular, the Ninth and Fifth Symphonies are his most famous, of course. And let's just say you just absolutely love the Ninth Symphony.
Okay.
So you decide you just really want to go back in time and talk to the man to understand how he created this beautiful piece of music. And you go back and you find out he's not even working on the symphony at all. And you go there and give him the idea of the Ninth Symphony. So the question then is, when you are here back in 2023, who composed the Ninth Symphony? Because Beethoven didn't do it without you, but you didn't even know the Ninth Symphony without Beethoven.
I don't know.
Yeah, like I say, it's these sorts of paradoxes. Like, could you make them logically consistent? Maybe. But again, it's always very shaky. And of course, if you can go back in time and cause the exact result that made you go back in time, goodbye free will, because you basically guaranteed that whatever decision you just made had to have happened and there was no other possibility. So if anyone is trying to argue for contra causal free will, libertarian free will, time travel makes that completely gone.
Yeah. Well, I mean, I don't think free will is a thing regardless of time travel, but yes, that's a fair point. Can you tell us a little bit about two things? One, wormholes, and two, potential like tears or rips in like space-time fabric.
All right. Yeah, those are definitely related because the wormhole, also known as the Einstein-Rosen bridge, named after the two physicists who first, again, worked out the equations of general relativity to show that, hey, it seems like something you can do that is consistent with the equations of it. You can generate these connections between two disparate points in space and time and seem to travel from one point to the other without having to take the long way around across. And then the idea is like, oh, that we could potentially travel to any place in the universe extremely quickly. And also you can work it out that if you have the two ends of the wormhole basically orbiting around each other at high enough speeds, you can also have it so when you pop out of the other end of it, not only have you traveled to a different part in space, but you've also done so back in time. So they can also become time machines potentially as well. So why aren't we building them right now? Actually, that's the other problem with time travel. Stephen Hawking had a way of testing for the existence of time travelers. He had a party, but only sent out the invitations a week later. No one showed up to the party.
Yeah, I mean, that's assuming anyone wanted to go in the first place.
I would.
I mean, same. I would love to go to a Stephen Hawking party. But,
So basically the question is, why is this actually something that is possible? And if it is, of course, it kind of begs the question, then why haven't we been visited by, some drunk teenagers from the future who hopped in their dad's wormhole machine and they just want to, visit us crazy 21st century hooligans?
Yeah, I mean, I don't think that I would select this moment in time to come visit, if I'm being honest. It's not great. But
given though the infinite amount of time that they can hop around, eventually someone's going to screw up and pop around here, it would seem.
Yes.
And again, if it's Doctor Who, for some reason, every single time his time machine breaks, it's in London or nearby or more specifically, it's a gravel quarry outside of London. Okay. So while the wormhole is consistent with vanilla general relativity, there are the questions of, well, what energy and matter conditions are required to make this possible, and does it present its own constraints? And among the issues that it has is that if you want to actually hop through and travel through the wormhole, you need to actually keep the wormhole open. But the problem is any matter will collapse it through gravitational interaction. So you somehow need some sort of anti-gravity to keep it open. And that basically says you need to find a piece of matter with negative mass. Now, if you look on your bookshelf for any negative matter, you're not going to find it. If I look back here in the Enterprise, I'm not going to find it. In fact, it almost certainly cannot exist because it would have all sorts of phenomenally weird properties. Amongst them, so imagine your car is made out of negative matter and you get behind and push the back bumper and it starts accelerating backwards. That's what negative matter does. It
runs you
accelerates in the
over.
opposite direction you push it, which is already screwed up. But even worse, if you actually have a piece of normal matter and a piece of negative matter, they'll have gravitational interactions. And the weird thing is, instead of the two objects being brought together by gravitational force, the negative matter will be accelerated away, while the positive matter will still be accelerated in the same direction. And now you have perpetual motion, and you can get infinite energy. And pretty much anytime physics says perpetual motion, you need to say, okay, kids, off the bus. Something's broken. This is right.
I won't be saying much of anything other than what's happening. What's going on here? I don't get it. Just kidding. Jimmy, if you're still in here, bye. I hope your headache gets better.
I'm not helping. I mean, you know.
What are... Let's see, how do I phrase this? Like, what are some of the things in physics, in the, I don't know, field of physics, that like make your brain melt when you try and think about them?
Oh.
For me, it's like everything, but you're an expert, you know? So you've got the good stuff, I know.
So there's a few things that could make my brain melt. One is just the mathematics required to do the thing is just so mind-numbing. So I was quite surprised when I took a class on general relativity and found the math in there easy. And please notice the very thick scare quotes I'm putting with there, because compared to some of the other classes I took at that time, especially in electromagnetism, which is a quote-unquote easy theory by comparison, but the mathematical tools for it are just so sophisticated, I literally took the classes twice and failed twice. They're just, you know, that was electromagnetism, and general relativity was easy by comparison. So the stuff that happens there, and the person who wrote our textbook, I'm afraid to ever meet that person because I think his brain would just melt me, just because he must have been so smart to even create the textbook we had to use for that class. And I'm not lying when I say I failed electromagnetism, in grad school, we considered anything below a B to be failing.
Okay, I was like, hold on.
Okay. It was bad enough that I did need to go and retake the class to have a better B. But still, that was difficult. The stuff I remember when dealing with high energy particle physics, the classes for that, the theory for that, you have a combination of extremely abstract mathematics, such as a group theory, wherein you are dealing with, you're not multiplying, dividing, adding, or subtracting anymore. The operators you're dealing with, you're basically saying, what are even operators, man? Let's be even more abstract than that. That's group theory. Which is really great to understand, like, even more general symmetries in mathematics. And this actually led to the discovery of new slews of particles. And funny enough, because the symmetries that were used had like these different, 8 different configurations, it became known as the Eightfold Path. Because they decided we need some more Buddhism in this.
Yeah, I was going to say,
theory.
this sounds familiar.
Yeah. Yeah, they took the naming from there, but the reasoning for it was much more mathematical. As far as I know, the number of Buddhists in physics is on the low side. It would be interesting to see a census to see how many Buddhists there are versus evangelical Christians. I know there's both, but I don't know the numbers. That would be an interesting census. Yeah, so like the math there is super difficult, but even that pales in comparison to fluid dynamics.
Continue.
Just the flow, just literally
I don't know
the
what
equations.
That is.
So, well, here's the thing. This thing is filled with fluid. You're drinking fluid. Fluid is the blood in our veins. Fluid is also the air, anything that flows. And the thing is, the equations that describe that literally cannot be analytically solved. That is, you can't do a finite number of algebra steps and get to a solution. So virtually everything that is dealt with when it comes to fluid dynamics has to be done with approximation methods. And if you want the approximation methods to be any good, you need a supercomputer. So, and this is a non-trivial thing to deal with, because especially like my kind of work deals with a lot of things that get related to aerospace and things like that. Well, you definitely care about fluid dynamics if you're talking about an airplane wing, because the way the fluid flows over that wing is the difference between flying and crashing.
Right, yeah.
And if you can't actually solve the equations analytically to show here's the best possible shape that you could have for a wing, and all that you can do is basically run super expensive simulations, man, it's really hard to make progress. So, you have, kids going into grad school to deal with fluid dynamics, and they'll spend, their entire careers on these tiny little esoteric bits of fluid dynamics that melts my brain to try to understand, and that's just one tiny little piece of this grand whole that is basically going to be our future if we want to fly into space.
Cool. No.
So
Digital Hammurabi, which
yeah.
I'm guessing, can't say for sure, but this is Joshua, not Megan. Here's the problem with this so-called doctor, Aaron Adair. He can't even prove to us why morality isn't ultimately grounded in the causation of instantiated presuppositions.
Well,
This is an
actually,
English-only chat.
So
Wait,
Digital Hammurabi, Dr. Josh, the causation of the instantiated prepositions is actually very simple, because I said so.
Super simple.
If we want to talk about the nature of morality and where ought statements come from, I can try to opine, but it is not my day job, so I will not be able to give a tremendous answer.
Yeah. Just never mind space. We have issues right here. Yeah, we certainly do.
Always and forever.
Oh, yeah. God, this place sucks. Okay. All right, chat. If you have any more questions, please send them our way now. I am going to ask this question, which is a very broad question. You wrote an entire book on it, so that's fine. What does if we are able to confirm some kind of extraterrestrial life, what implications does that hold for Christianity?
So it is going to obviously depend on which Christian group you talk to. The thing that I was surprised when doing this research is the group of Christians that are going to have the absolute easiest time accepting this are going to be the Mormons, far and away.
Yeah,
they have been pro-alien.
You're going to get your own planet.
Yeah, they effectively say that God is an alien from the planet Kolob.
All right.
So in a way, if we discovered aliens, there's some among the science fiction I've read, the stuff that has gone into the Amazon series, The Expanse, the group of people that are trying to build a ship to go beyond the solar system are actually the Mormons. They build this giant ship so that way they can basically bring Mormonism to the stars. And honestly, I think that is probably the most realistic part of the show itself. Among many other things that actually I think have a lot of realism, both in terms of science and sociology, that basically all the issues that we have of classism, racism, things like that, well, just because we have fusion engines and can go between the planets doesn't mean that's going to be gone. It's just that now, instead of it being Americans versus Chinese, it's going to be Martians versus Belters. It's unfortunately plausible what is depicted in the books and TV series. But nonetheless...
Sorry, that's what I was looking for. Heaven's Gates. Yeah. It would also work very well with them.
Well, the 4 members that remain? Yeah.
It would have worked very well with them.
Yes. Though there are several still active UFO religions. In fact, when I was writing the book and first announcing it, I was being contacted by one person from the Raelians group. Rael was this Frenchman who said he was contacted by an alien, like landed in front of him UFO style back in the late 70s.
For sure.
And I think he also says like the aliens are called the Elohim and they're going to be coming back in the 2030s, if I remember their timeline. I'd have to double check their website. The details escape me.
What is it that Dan says? Pure and utter nonsense.
It's at least unsubstantiated. Yes. I only point out that it's still, a more plausible statement than a deity is its own father and son and spirit at the same time. But what do I know? Again, I can't, substantiate the moral aptitude of the uncaused causiness.
That's a word salad.
Yes, I try my best. throwing some tomatoes into there. So, but the many of the views of God and humanity are going to have to change, especially for Christians, because there's supposed to be this special relationship between humans and the God of the universe, but even sometimes even more specific, a specific subset of those humans. But then if you find out, hey, God isn't just making a special covenant with one subset of humans, he's also making it with one subset of all the possible intelligent species in the entire universe. So it's like, okay, why are we the special ones and not the aliens around Omicron Persei 8, for example?
Do you have a channel? Sorry.
I do have a YouTube channel, but it is mostly covered in cobwebs. So it is searchable for me. I forget what the handle is off the top of my head.
That's okay. I can get it to Jay later. But Jay, I think I messaged Jay. So sorry. Hunter Biden's laptops is a guy named Jay. Jay, did you already finish your PhD, or are you finishing it in astrophysics? But I was telling him about your book, and I would love to have you both on at some point to like talk, and then I'll just listen. Yeah, anyway, I'll let him answer that question, and then whenever you remember your YouTube channel name or look it up, I'll send it to him.
Yeah, I'll look that up later to send off, but...
oh, shit, sorry, it's evolutionary biology. Never mind. It's not... Sorry, Jay.
Or I was hoping we'd get into an argument about if Pluto's a planet or not.
Damn it. Yeah.
All right, but to the question of how religion is going to have to change, and among the issues that Christianity is going to have to confront is how does this work, especially in terms of the incarnation of God's only begotten son? Or does God have a whole lot of sons and we were just totally told about one of them? Or does Jesus have to hop around to every single intelligent species in the universe as they emerge over time?
Did Jesus have to die like over and over and over and over again?
That is one of the questions that has to be answered, and is one of the top questions in what is called astrotheology. And when I say astrotheology, I don't mean the zeitgeist, Jesus mythicism version of that. Astrotheology is the idea of applying a theology to the subject matter of things that relate to space, space aliens, and the like. In the same way, astrobiology is the scientific subject of studying biology off the Earth, and especially around other possible planets, maybe even closer to Earth, like the moon Europa, one of the moons of Jupiter, because we know it has a liquid ocean underneath its surface, and it is speculated something could live there.
Something like what?
That, like I say, when we say something, we have to be extremely broad. It maybe it is just the most
like
absolute. Yeah, it could be even more basic than that. Like, you know. Here is what would absolutely rock our world. We are, when I say we, like we humans, are trying to make missions to go to Europa, and we have to basically drill through like several kilometers of ice to get to the oceans of Europa. And imagine we could do that. We can finally get some sort of submarine to go down there. It turns on its light, it starts swimming around, and if something all of a sudden came up and licked the camera lens, all of biology would just, be overturned in one day. Bam. Wow. There is complex life on another world without even the need of the sun. The possibilities for life in the universe just explode in number.
Where am I getting nailed today, Dad? What? Yeah, sorry. I'm making jokes, but that's actually a really wild thought.
Yeah. Yeah, it is one of the active possibilities. Now, nobody knows for sure. It really could be the case that the oceans of Europa are completely inert. Though the fact of the matter is there is liquid water there. And the adage for NASA right now is when it comes to finding life, follow the water. When we are looking for possible places where life does exist or existed in the past, the question is, did it have liquid water? Because as best as we can tell, liquid water is a prerequisite for life.
For life, right. What outside of liquid water is it considered a prerequisite for life?
Well, water is just the best because not only is it the third most abundant chemical in the entire universe, so you got plenty to work with, but also the fact it can work as what is called like the universal solvent that is just so good for like, mixing up chemicals together so they can properly interact with each other. that is an advantage. But if you wanted to go to another world and maybe have some interesting, strange chemistry, we can still stay in the solar system. But if we go to the planet Saturn, one of the moons there is called Titan. It's the largest moon in the solar system. It's so large it actually has its own atmosphere. It's also absurdly cold there, so much so that there is a liquid on its surface, and we've actually been able to send probes on and land on this moon. And the liquid there that's flowing is not water, it's methane.
Oh.
Now, it's not the case that if you like strike a match, all of a sudden the whole moon will explode because there's no oxygen to burn there. But nonetheless, you have literally lakes, rivers, rain in the form of methane and ethane. And the thing is, could those also act as solvents? And not to mention, methane is itself a hydrocarbon, which is a precursor to most biological molecules. So if you literally have a planet swimming in hydrocarbons, could it literally be swimming with hydrocarbon-based life? It's an open question.
You know?
Yeah.
You have to leave the tools at home. And I said this at the beginning of the episode, and I'll say it again. It's, as someone who grew up as a young Earth creationist, like fully indoctrinated in like the Ken Ham way, answers in Genesis, just absolute nonsense. I was taught that like we have the answers for everything ever, and like we are the center effectively of the universe. I mean, obviously like not the physical center, but like God created us to be in relationship, and we are the only sort of race, I guess, that exists. And the way that it happened was poof, he said it, here we are. Like I literally, a phrase that went around in our circles was like, yeah, I believe in the Big Bang. God said it, and then bang, it happened. Which is just like, y'all are so fucking corny. Just the corniest. But like, yeah, it's just so wild to realize all of the things that I never ever even considered or knew, and the complexity of it all. I do also want to mention, because we put that comment up on the screen about Pentecostals. So I technically grew up non-denominational. However, I would describe it as Pentecostal, and like, yeah, they will always just find a way to integrate whatever nonsense and call it a demon or a spirit, because like their entire worldview is that everything is this like spiritual warfare, and like it would just be anything they don't understand is against God, and yeah. So I mean, I could definitely see that. I mean, if they can convince themselves that Trump is sent by Jesus and is saving us from evil, then aliens isn't even hard.
Yeah. Among the things that is difficult to swallow in theology, I mean, yeah, the Trinity is one thing. The need for blood atonement is another thing. Trump is the equivalent to Cyrus? Oh my goodness. No, that's way harder to swallow for me.
It's not even Cyrus. I saw someone the other day compare him to Jesus.
Oh, yeah.
Like, all right, here, fine. Nail him to a cross, give it 3 days. Get back to me, Anyway, sorry.
From what I understand, the district attorneys across the U.S. don't use that punishment anymore.
That's
most of the time.
Yeah, so I'm an abolitionist, but when it comes to Trump, I'll make an exception. Whatever.
I understand the sentiment, but I think we both will hold to the higher standard.
Boring.
All right,
I want to be the smaller person. No, okay. I'm just kidding. Okay.
But it's also worth noting that, yeah, with the background that you had mentioned, that's also going to be the group that's going to have a hard time struggling to explain themselves, because like Ken Ham in particular has come out and said like there definitely aren't any aliens, but of course he says that with an Australian accent that I'm not going to try butchering. I don't want the entirety of Australia coming after me. I got enough enemies as it is.
How do you have enemies? You're like the nicest guy.
Oh, we have the most severe enemies, because it's like, yeah, who gets angry at that? That must be some terrible people. But basically, like, the people at Answers in Genesis, they have already declared aliens do not exist. So if we detect them, how are they going to spin that? That is among the problems. And here's the thing. We've already seen in some cases historically what has happened to Christianity when even the proposal is on the table. And I have to bring this one up because even modern Christian scholars are either ignorant about this or just straight up lie about it. And it's about what happened to the Italian philosopher, magician, Giordano Bruno. And, he was not a scientist, definitely not in the modern sense, but he was pushing some of the concepts that we do consider scientific, such as the Copernican system of the solar system, and in particular, the infinity of worlds, the plurality of worlds, as it was often called. And he literally argued that there are an infinite number of stars. All those stars are just like our solar system, so they have planets, and with an infinite number of planets, some fraction of them will have life, which means a fraction of infinity is still infinity. There are worlds with people on them. And this we actually have found in the court records that were rediscovered in the 1940s from his trial. And apparently the biggest bugaboo for the Inquisition there was the plurality of worlds. And that was part of the condemnations of him, and that they put him in the stake and burned him alive in this square in Rome in 1600. And that was just for pushing the idea. What the heck would happen, of course, now if the aliens literally land in Rome in front of the Vatican? Now, the current Pope says he's totally cool with it. He's totally cool with it. But,
sure, yeah.
Again, if the aliens come out and they're just like, this whole salvation thing you keep talking about, that's not for us. This makes absolutely no sense to us. Or conversely, the aliens come and they're Muslim. Who knows what kind of religion aliens might have, or if it's even a category for them. That will be an interesting sociological experiment once we encounter a completely different kind of sociology.
Yeah. Well, I do think it's really interesting to think about, as you're saying, right? We as humans, I was listening to Forrest Valkai talk a little bit about this the other day. We set ourselves at the top of the hierarchy, right? Like we are the most evolved, and therefore, like, everyone is aspiring to be, or not everyone, but like we assume everything is trying to evolve to be like us, right? But like we really don't know what life could be like somewhere else. Like we have no idea. And they could be any number of things, like to any degree of evolution that we can't even imagine. Mm-hmm. And so it does seem very like, I don't know, self-aggrandizing maybe, for us to think that, like, one, aliens want to interact with us, but two, that they would even present or behave in ways that are similar to us at all, right? Like these sort of social categories of like religion or ethnicity or nationality or whatever, like that they even exist elsewhere. We're just projecting our own sort of ways of understanding and dealing with the world onto a potential subset of beings that might really have nothing to do with us at all. Like,
and all the more so depending on what their technology is, because we've been imagining our cyberpunk future as we integrate with our technology. But if the aliens are like cyberpunk 2070, that is so old hat. We're in the 50,000th century in our world of technology. So, all those ideas of those, biological sorts of categories just become incoherent if your entire civilization is now basically in silicon form.
That's wild.
But yeah, that, of course, I'm speculating about a technological future of a society that we can only speculate about if it even exists. So obviously it's a house of cards to think about what that might look like. And so, from what little bit in our book we have when we try to talk about what might alien religion be like, we basically say, more likely than not, it's going to be at least as diverse of ideas as it is for humans. And since with humans we have everything from, monotheism, polytheism, everything is God, to there's no God at all, or even the concept of disembodied minds just doesn't even make sense. There's going to be at least that much diversity for the aliens thinking about these sorts of things.
Do you think that we're living in a simulation?
I think not, and for the best reason I can give for that isn't based on um, the ideas and countering the ideas of like, can we even build such computers that could even do these simulations? But it's kind of basically the simulation problem of evil, I would put it. If someone was to create a simulation and it includes the Holocaust, that sort of person is a moral monster. And why are moral monsters getting access to this much compute power just to cause that level of suffering? That does not seem like what a simulator would do. If anything, what they're going to want to simulate are paradises.
Right, because I would assume that simulators are trying to create the maximum level of like efficiency, I guess.
At the very least, the idea that you would create a simulation to make things suffer, to create conscious suffering, is morally repugnant to the highest degree that even Nazis would probably flinch at least some Nazis.
Yeah.
So I would think, so to me, it's kind of like, if there's any sense of social responsibility for the creators of these supercomputers that we're imagining, if they have any sort of moral character, they're not going to produce Holocaust simulators.
Right. Yeah. I will say, so two things. One, I want to respect your time. We're at an hour and 40 minutes. I'm going to give it like 10 more minutes. If any of y'all have questions, it's now or never, baby. Like, put them in the chat, super chat them, whatever, and then we'll ask before we go. I did also want to mention this because like this is just funny to me. The other day on Twitter, somebody said that yoga pants were Satan's greatest creation. Yoga pants, not the Holocaust. Yeah. Like, well, if you don't believe in the supernatural, then like why? I'm not joking. This is literally what you said. If you don't believe in the supernatural, how do you explain all the free porn on the internet? How do you explain that I think about sex so much? That's what he said. I mean, I can explain it. It has nothing to do with the supernatural.
Yeah, it boils down to one word: hormones.
Exactly. And he's like, yoga pants are Satan's best creation. Like, honestly, that just sounds like a dunk on God to me. Like, Satan created yoga pants. Like, that's a dunk on God. That's all.
Yeah, I mean, if we end up in hell and we find out, hey, everyone's wearing yoga pants, so I guess we're going to have light exercise and be comfortable. Okay. Yeah. All right.
And
I'm
people's
good with this.
butts are going to look excellent. Like, I don't know. I can't explain the fucking magic behind them. All I can say is that they work, you know? All right. Any questions? If not, I'm going to ask the good doctor to let us know where we can find him, where we can buy your book, how we can support you, etc., etc. Just like plug, shield, do your thing.
All right. Yeah. So I believe I have all of my socials packed together on my website, draaronadair.com. That's where you should find like the links to whether it's my Facebook, Twitter, YouTube account, LinkedIn, CV for myself, so I can somehow present myself as somehow worth listening to, or a very good liar, depending on how much you trust my CV. The book itself, the plan is that it should be coming out probably early April. If for no other reason, I'll be giving a talk locally here at MIT on the 13th. So if I don't have books to sell then, I've really failed at this thing called marketing. I'm also, of course, doing this with my co-author, Jonathan M.S. Pierce. I would also suggest, finding out his channel because he does lots of good conversations, deep dives into philosophy and religion. Basically, we first had a conversation about this based on another philosophy paper and then just decided, let's turn this into a book. And it's been really fun working with him on that. Also, patronize him because he's also very deserving of that sort of attention. Otherwise, best thing to do to support me is support the channels I go onto because, they're the ones doing the actual hard work. I'm just sitting here drinking beer.
Yeah, I don't know if I would call what I'm doing hard work. I literally showed up and said, I'm an idiot, and then let you talk. So thank you for the super chat. Thanks for the fascinating conversation. It was truly my pleasure. If you're open to it, would really love to have you and your co-author at some point And then also have you and Jay come on and talk about what? I don't know, because I don't know anything about science. If you all want to talk about economics, I'm your girl. Um, but yeah, that would be awesome.
Well, we could try talking economics too. We can debate what's the best shape of the Laffer curve.
The best shape. I mean, there is definitely a mark or a mark, a point where it makes sense to reduce taxes. And oh wait, hold on. What do you think of the claim that UFOs are daemons?
Oh, that's just a straight up fact.
Facts.
Actually, this is a bit interesting because I have found some diversity within both Christianity and Islam about the relationship between UFOs and supernatural beings. In earlier Christian literature, and when I say earlier, I mean earlier back in the 20th century, some of the people were arguing that UFOs were actually angels. And actually that UFOs explained the various miracle stories from the Bible, from the parting of the Red Sea, that was UFO technology, Jesus going up into space, obviously tractor beam up into the mothership, things like that. And the thing is, when I'm saying that, I'm not being facetious. I mean, this was literally proposed by some theologians to basically keep Christianity consistent with science. But as stories about abductions became more negative, especially the stories about,
Being like
negative sexual encounters and probes and things like that, then it became much more demonic things. And so more often than not, if UFOs are treated supernaturally within Christianity, it says, yeah, there's some sort of demonic force. And from what I've read as well in the Islamic world, it's actually rather common, the ideas of both ancient aliens. Unfortunately, that's apparently popular in Iran and places like that. Relatively popular, at least. They're actually reading Eric von Daniken and other authors about that sort of stuff. Those who are still more supernaturalistic will say that the UFOs are actually driven by the jinn, the more demonic.
The genies?
The genies.
Okay.
Yeah.
Good Lord.
Yeah. Now, as far as I know, none of these drivers of the UFOs sound like Robin Williams, but I would like to imagine at least one does.
I should hope so. Yeah. So this is just totally random and like conspiracy theorist. So don't take this seriously. But like, what is your, like, do you think everyone that claims to have been like visited or abducted by aliens and like probed, like, do you think that's just like hallucinations? I mean, I don't expect you to take this actually seriously. Yeah. I'm just like, what is this?
There's probably a large diversity of causes in some cases. Now, in probably a rare subset, it's just straight up lying. But I believe that's probably the minority, because
you don't get a lot out of it. I mean, people think you're crazy.
Right. But the thing is, though, there is also a sociological aspect to it, because if you were plotting out what do the aliens look like, and I ask you, like, what's the stereotypical alien? What's the shape of their body? What would you say?
I mean, it would be like what I've seen on TV and how other people have described them, because that's quite literally the only reference point that I'd have, and that's just what other people have said.
And that's
it's basically like a human body, except for not really. It's like a weird distortion of it, but it has like arms and legs and a head and hands of some kind and like feet. So like it's just a
The thing, though, is most images that people have of aliens in their abduction experiences are actually even more tightly bound than that they are usually have like a bulbous head, kind of large wraparound eyes, almost no nostrils, very often gray skin, diminutive in stature. It's in the neighborhood, yeah. But the thing is, that view of what the aliens look like only started happening after the most famous abduction case started going public in the 1970s. What happened in the alleged case of Barney and Betty Hill. And the thing is, what they describe in their sessions, where they were supposed to be basically not hallucinating, but they were basically undergoing some level of hypnosis to try to retrieve their memories. And in the stories that they give and try to like draw out what they had seen, it looks like what they probably saw, also based on when they said they had the encounter, is what they had probably seen shortly before their sessions on a television series called The Outer Limits. I don't know if you've ever heard of this series,
Yeah,
but it
I
was
have.
basically on, yeah, but in particular, like the version that was on around the same time as the Twilight Zone in the 60s. And they had an alien that kind of fits that description. And that's basically what was on TV like a couple weeks or the week before they had their hypnotherapy session. And then once that story becomes the well-known one, when other people start talking about their encounters with aliens, it seems to do and more conform to that story, and any other variations in that story then also start to influence other people's experiences. So to me, I see this much more as a sociological, psychological phenomenon based on data like that. If you go back further in time, what do the aliens look like? Well, like one of the early contactees back in the 1950s, a guy by the name of George Adamansky, when he said he saw the aliens, they were just, these beautiful, tall, white Norwegian-looking creatures.
All right. Sounds like
So
how we've
Norwegians
started
are
to
aliens.
imagine angels. Yeah, I wonder, this is totally off the cuff. I wonder what the sort of like psychology is behind sort of like conceptualizations of non-human life, right? So like, yeah, if you look at like, I know this is kind of a joke on like Christian Twitter, TikTok, whatever, like biblically accurate angels, they look wild. But like if in sort of like popular culture, the way that we think of angels is very much like that, right? Like tall, bathed in white, glowing, beautiful. And so I have to imagine there has to be something sort of psychologically going on there that's interesting. Yes, space Vikings.
In the case of Thor, especially, yes.
Yes, yes.
But of course, it also depends on the experience. Like some people also have like, these terrible nightmare situations and their aliens are much more horrendous. But it also looks like they are having the original nightmare. Like the term itself was for this sort of creature that sat on your chest that made it so you couldn't get up. But
it's sleep paralysis.
Yeah. And that sort of phenomenon is, all around the world, and each culture has its own variation on that. And now it just looks like, in some ways, aliens are kind of like fitting in that same cultural template.
Right, yeah. Yeah, the original angel descriptions were way cooler. Yeah, and now we all know why they said things like, be not afraid. It's because they were terrifying. It wasn't like some like nice man that's glowing white. It was somebody with like 25 eyes and like fire shooting out of everywhere. Like I'd be fucking scared too.
And if it even is humanoid, it's often carrying like a flaming sword. So it's like, yeah, be not afraid. I just got this giant flaming sword
Maybe
here.
just put that down and then I won't be as afraid. Like just relax, have a Diet Coke, quit shooting people. All right. So let's see. Sit on your chest or stick stuff up your butt. I see a pattern here. Yeah, it sounds kinky. Sorry. In any event, thank you so much for sharing your knowledge with us. That like I feel like I've learned more in the last like 2 hours than I did in like 3 years of school. This has been fascinating. I super appreciate it. I would love to do it again. Yeah. Any parting words for the people?
You're probably going to see my face across the internet as I continue to promote this sort of stuff. I'm very happy to come back and answer more questions or argue any of the other fine points, because this is a subject that touches this is a topic that touches so many different things.
Yeah.
I think it's fun, it's interesting, and there are so many interesting unknowns as well as knowns that can just be mind expanding in the best ways possible. And most importantly, we can have opportunity to nerd out, guys.
I mean, that's my favorite thing to do on a variety of topics. It's just sometimes I have more to offer than others. Yeah, but like we really didn't even touch on many of the things in your book, which I'm sorry. It's just everything else was so interesting and I couldn't help myself. But like the book itself is really interesting. I would love to sort of work through it with you a little more like systematically for people. We talk about, I just got here. Sorry. I don't know. He has a family, people.
I have some time. If he's got a question he wants to burning, I'm happy to sit here and answer.
All right, so why don't we do this? I really need to use the restroom, so I'm going to put myself on pause. If you have a question, please answer it, and I'll be back in like 60 seconds. We good?
All right, I will do my best. I have the chat up, so if a super chat pops up, I should be able to see it. All right. All right. So I definitely do not hear you. So
sorry,
you are
Correa
muted.
should still be here, so they can also. Yeah. Thanks so much. Be back.
All right. Super. All right. All right. In the meanwhile, I shall also just give a couple other things. So among the things that was really fun to do in this is the book had the opportunity for me to actually do some math. Now, that might sound like a scary thing that makes you want to run away, so don't worry, I do the math for you, but it's probably going to be the only theology book out there with differential equations being solved. I found it interesting that there was a previous philosophy paper arguing about what happens to the problem of evil if extraterrestrials exist, taking the idea that whatever horrendous things have happened in our universe, and plenty of terrible things have happened, we're probably only experiencing what's the average for the universe. Again, the Copernican principle is that, hey, we're not in a special place. We haven't had special experiences. So if there are other aliens out there, what terrors have they gone through? And if we think the tsunami of 2004 was just egregious suffering without explanation on theism, and we think that's at least some evidence against an all-good God, what happens when we find out aliens exist, and if they exist, almost certainly have experienced even greater evils? So this was a philosophy paper, guy by the name of Samuel Rumkoff. When Jonathan and I were looking at it and looking at the math he was doing there, we realized we could actually keep going, and we actually created a math function to update the probability of the evidence for or against God based on the problem of evil, assuming aliens exist. What happens if aliens exist? What happens to that probability? So, like I say, this would probably be the only time you're ever going to see a differential equation come up dealing with a theology question. And I, for one, think theology will be the better for it. And I, try showing my steps so that way you can follow the math there and see if it's holds up to scrutiny or if I'm just making up numbers. Hello.
Hi, I personally very much enjoyed the differential equations. I flipped to the back to look at them because, economics. Yeah, I liked the math. I know it's not for everyone. I'm certainly not I'm not on your level with math, but I did nerd out on the math a little bit. Not gonna lie. All right. So here's the thing. I'm good to go for however long. It's 6:00 here. I have nothing to do.
I have beer in my mug. I can keep going.
Great. I just want to make sure I'm not keeping you beyond yes, that's all. All right, cool. So you let me know when you need to go.
Let's call it in, say, 15 minutes, just to make sure I also respect your time.
Oh, it's I'm doing nothing, but yeah. I don't know what this means. What do you think of
I do.
Three Body? Yeah, great.
Okay, so that is a literal reading of the Chinese title, Santi. The usual English title is The Three Body Problem by the Chinese author Xin Liu. I have not read the book in the original Chinese, just English translation, but it's an extremely well-respected book. It actually won the Hugo Award, I believe, or is it the Nebula Award? I forget which science fiction award it won for that. So The Three Body Problem came out 2005 or so, and it relates to humans' first contact with aliens, and the aliens basically find out we exist, and they're like, hey, our solar system absolutely sucks. We're coming to yours and taking all your stuff and killing you all. And this also then sets up to what is in the sequel, what is called the Dark Forest. That's the name of the book, and it brings up what has now been relabeled the Dark Forest hypothesis. It explains why is it the case we don't see extraterrestrials, because one of the questions in science is hey, if we're predicting there are billions of planets in the galaxy, and we think life is likely to pop up from them, why aren't we just being flooded with signals from intelligences? The hypothesis in the Dark Forest system is they're out there, but they're all trying to shut up because they realize whoever is talking, whoever is making noise, is getting the attention from everyone else who's afraid of each other. Because there's the worry that someone out there is more technologically ahead of you, and if you speak up, you are showing to be a potential threat and you need to be annihilated. And everyone has the same game theory going on in their heads, so everyone is being quiet. So they're out there, but they're all doing their best to stay hidden.
I love game theory, but yes.
Yeah. We do some analysis of specifically the dark force hypothesis in the book, and I show that it actually has some limitations if you do go through all the game theory steps. And show that there are some ways of getting out of the dark forest to try to light it up a little bit better. Not to mention, I also showed that if the dark force hypothesis is true, it also basically shows that we'll never find super advanced aliens because they would basically have to nerf their own technological development because otherwise they would be too noticeable.
So just as a heads up, we have a couple of questions. I did say that super chats were going to be prioritized. We will get to the other questions. I have starred them. But this is the super chat. So your mention of PoE in the context of ETI reminded me.
The problem of evil in the context of extraterrestrial intelligence.
Mm-hmm. Reminded me. I'm not sure I know.
Oh, because he mentioned the three body problem book from before.
Oh, okay.
And that basically, I guess you could also say this could be a problem of evil in that a universe that's created where everyone has made the rational choice to be out for everyone else's throat. Basically, you take Thomas Hobbes, but basically put his theory of the state of nature on crack and just make it as dangerous as possible.
Perfect.
Just fill the universe with cocaine bears.
Yeah. Are the mathematics for the differential equations reproducible for a simple person like me? Is it like open source?
So specifically in the book, it's an appendix so you can follow all of the math steps. If you want something that is reproducible as source code, the one thing that I also did was that I tried to do my own simulations on how many civilizations are in the Milky Way right now. So what are the correct parameters to put into the Drake equation? I created a code base for doing that and showed my justification for that. And I put my code up in my GitHub repo. So that way you can download the code and run it with the Python programming language, which is free. And if you don't even know how to run Python, I even put a link in there. So you go to something that's called Google Colab. It's basically a free computing resource from Google. So all it does is basically it opens up in your web browser and you can just hit the run button and just let the code run. So you don't even know how to set up your own coding environment. You just literally press a button and it'll reproduce my results.
He did it for you. I have a question that's like not related or barely related. What does your wife do?
Many things.
Well, of course, but I mean, like, is she in your field at all, or is she just does something completely different?
She has had such an adventure of things she has bounced around in. So
I love it. I feel
she
like
also
I do
has a
thing.
PhD, but it's in English. But she's also earned a master's degree in supply chain management and another master's degree in international relations.
Oh, my kind of lady.
Yeah, so she's, bounced around and done a whole bunch of different things. She was also able to do all that extra schooling because she served in the U.S. Army for a couple of years, so the GI Bill helped fund some of that.
Get it. She
yeah,
sounds badass.
Oh, yeah. Though I will admit the one thing, and this might embarrass her a little bit. So when she's
sitting next to you, did you just look at her?
No.
I thought you looked over at her like, don't be mad.
If she watches this recording later. But
okay.
So when she was in the Army, she was part of a, what's the right term? Jump unit. People basically jump out of planes.
Okay.
I forget the term. So like every couple of months they would have to go and practice and like fly up in a C-130 and jump out with your parachute. And of course, I'm pretty sure I would be wetting myself the whole way.
Oh, yeah.
But she had to do that. But the thing that surprised me, and we went and did some zip lining up in New Hampshire, and I thought I was bad with heights, but she seemed to be worse. And I'm just like, you literally jumped out of a plane. How can I be better in this safer environment? Come on.
Someone says airborne. Someone else says paratrooper.
Airport. Okay, yeah.
Airborne paratrooper. We'll go with both.
Yeah.
Yeah, I don't actually understand that. I don't know how you jump out of a plane while also being terrified of heights, but like, get it. I can't even be up like I went to Vegas for my 25th birthday, and I don't remember what hotel we stayed at, but we were up super high, and the balcony had like a glass railing. I don't know,
Mm.
like it, and I struggled. Like I was like, yeah, I can't really spend a lot of time out here. Like it's too high, and there's too much glass.
Yeah, I
Um,
get a little bit nervous as well.
yeah,
Like we actually have in our apartment complex, we do have a balcony here, and if I'm on there, I get a little bit nervous. I can feel the tiniest bit of slope in there, and thinking it's going to throw me off the edge. It's just,
I just
yeah,
start thinking about
I'm
like
not great with
earthquake.
heights.
Yeah, I mean, I do live in California, so that's like the other thing when I'm up really high. I'm like, huh. I wonder if this building is reinforced for earthquake. So if everything
Hmm.
starts to shake, where am I going? And then I just want to lay flat on the ground. But that's fine. So let's see. Was Bayes' theorem or any Bayesian inference used, if any, in the math you just spoke of? Hope this makes sense. Then
Yes.
Farron said that what he asked was probably nonsensical, but I don't actually think it is. I think it's probably useful, but I don't know.
Yeah. I thought the question was coherent, but yeah, did we apply Bayesian inference? So basically, did we start with some prior probability and use evidence to get to a new probability to come to a more defensible conclusion? And the answer is yes. The way that we dealt with the problem of evil and the updating with the discovery of aliens, that was straight up application of a prior probability distribution, then a posterior probability based on updating with Bayes' theorem. And yeah, all differential equations along with, some of the necessary arithmetic to get to that. And also for the projection of how many civilizations are in the Milky Way, I was originally doing this based on a paper that came out from a group of researchers from Oxford who basically said, here's like a prior probability distribution of how many civilizations are in the Milky Way, but let's update it with the fact that, hey, we haven't detected any radio signals. And they used Bayes' theorem to basically say the more civilizations are out there and the fact we haven't detected them, that's more unlikely than not, so that should count against it. And so they did have a way of doing that updating. I repeated that analysis, but I also found that because my prediction for how many possible civilizations could exist in the Milky Way was lower, it didn't update near as much as it was in that original Oxford group paper. I also found other issues with that paper that I detail to try to show that in one case, science better than maybe someone else.
There you have it. All right, so many I can't talk, sorry, habitable worlds. I'm very smart, okay? I got accepted to the University of Chicago twice. I just can't read that good. Just kidding. Anyway, with many races that evolved in a variety of environments, do you think that may dramatically affect their morality, or would their ethics be more a case of convergent evolution?
So I think the evolution of possible moral systems might be constrained by the fact that you really can't evolve antisocial behavior and actually have that group survive well. So I don't expect the aliens to necessarily have identical ethics as us. And a lot of things can really complicate that because, a lot of our ethical questions also depend on questions of race, class, gender, things like that. If those categories just don't exist for the aliens, then the discussions don't happen. And conversely, if they have categories that exist for them that we haven't even imagined, that's going to create another interesting dynamic. We could also even imagine, what if there's a world that actually had two civilizations develop on it, like two intelligent species, but one is clearly more intelligent than the other and creates almost a natural master-slave system. Would that potentially be moral? I would hope that I could argue it wouldn't, but how would I convince these other aliens who can say, no, it is completely natural that this group is clearly dominant in way X versus this other group? That could create conundrums that we can only right now imagine in science fiction.
And I mean, it's not a one-to-one at all, but very much for a large portion of our history, we as humans believed that there was like this divine order, right? This divine natural order in which certain people were, for whatever reason, superior to others. And if whatever station you were born into in life, like that was where you were meant to be, and you're not supposed to question it, right? And so in like a similar but not exact way, if you have these two races, I guess, on another planet, like it's not hard to imagine that like in their own minds they could justify a hierarchy that we really couldn't talk them out of, right? Like,
Yeah.
yeah, I don't know.
I also have a wonder as well of what would happen to our morality, and our interpersonal ethos if we discover aliens exist, because so much of how we divide up friend and foe and, create in-groups and out-groups, is based on national lines and things like that. But if we say the aliens are out there and they're out to get us, we could easily us them and just have the us be all of humanity. So all of
Right.
humanity is united to hate those fuckers.
Yeah, I mean, so what in undergrad I double majored in economics, as you know, and international relations. And on a very, very basic fundamental level, it's wild to me how much we define our identities by made up lines. Like we just put some lines down and decided like this is where we live, right?
Yeah.
And I mean, if you look at like even the Old Testament, I've been doing some reading on David and sort of what we can know about him historically, and like likely he was a military leader of Judah. And the Philistines would have had to get through Judah to get to the rest of Israel, but Israel at this time was not like a political like state as we think of it today, right? It was very much like there were tribes in the north, and they were all individual tribes. And then when there was a threat, an external threat, then they would send a judge from each place and they would have a sort of united front. But like so many of the ways that we divide ourselves today are just made up. We just made it up. Like we just made them up, right? And so like if there's this external or existential or whatever threat, I think we could easily get rid of all of those and just be like, yeah, we have to survive. And
Yeah.
yeah, anyway, sorry.
Yeah, I mean,
rambling.
in particular, yeah, with like, the creation of the nation state. And we even use it to say, well, we're going to unite people based on language. But even what's called a language will then depend on what borders are drawn there and what they're going to say. Oh, and this is the language of everyone. It's like, but we don't quite speak that. Shh, shut up, shut up.
Sure, but in like a globalized world like we're living in now, it's becoming, it's not there yet, but it is becoming sort of like the English is becoming the global language in a lot
Yeah.
of ways. And
Right.
so like if you're defining it by that, then like you could say anyone that speaks English is a part of X group. Right? And I mean that
Yeah.
doesn't lend itself.
Oh, I only say that like in that what it gets called a language will usually then try to like cover up all the different variants and dialects across there to try to show more homogeny and show greater unity
Sure.
than actually exists there. Like I see this like, I've been learning Chinese, and the version of Chinese that's taught is basically here is the accent that you hear just outside of Beijing, and now we're going to say this is the Chinese for the whole country. But literally, if you're in southern China, you listen to it in one town, you go down the road and you can't even talk to the other people, but they're all speaking Chinese. Really? There's actually this Yiddish phrase. I can't say the Yiddish, I only know the English, but the difference between a language and a dialect is that the former has an army.
Yeah, well. Yeah. Thank you for another super chat. Appreciate you. To ponder, original sin via the ETIs. Would it propagate to other races, including ones yet to evolve? Would each need its own original sinner?
Yeah, this also relates then to the incarnation problem as well, because, if Jesus has to come back and save people from their sins, what if you have an alien race that is unfallen? So in particular, funny enough, one of the people who thought about this idea was C.S. Lewis, and he imagined aliens on Mars who are unfallen. That they only even get like bad ideas once some humans start showing up and making a mess. But
C.S. Lewis was into kink, just so everyone knows. But yeah, sorry. I feel like everyone needs to know that.
I think the world is better knowing that. Okay.
I do. Yeah, I think so. Because everyone's like C.S. Lewis, the ultimate Christian. And I'm like, maybe. But also, if you're going to say that, then you should know because y'all are
Yeah.
Puritans. Sorry.
Yeah.
I'm
All
taking
right.
it a different way. Yeah,
That's
go
okay.
ahead.
But yeah, here's we can imagine a few things. So one scenario is there are alien civilizations that just never sin, they never fall, they always have the best possible relationship with God. They are stay in the state that Adam was supposed to have had and never fall away from it. In which case, it begs the question: then why is it that this model of creation fucked up?
Right. Yeah.
If
Where's the glitch?
just yeah, so I mean, it becomes a case that wait, God can create a species that is intelligent but doesn't sin. Then begs the question why we can't be that kind of creation. That becomes a bit of a problem, and also the idea that if Adam's sin actually does penetrate through the universe, well, they're very likely if there are other civilizations evolving, some have actually evolved and existed before we did. Did they also have to suddenly see their entire universe, world collapse because some guy ate an apple on some other planet? Weird things like that start popping up, or otherwise, as Sohan is mentioning here, does every single planet have to have its own original sin that each one has their own snake/Satan to worry about?
The fact that we really are still, like, not you and I, but like people generally are still thinking that there's like talking snake. Like, I'm very tired. Someone the other day I saw on Twitter was like talking about how feminism is demonic, and their like evidence was the talking snake in the garden. And then people were like mad that I wouldn't like intellectually debate this person. He's referencing a talking snake. How am I supposed to debate with this person? Anyway, sorry.
Well, you could, but you would have to do it in parcel tongue.
Yeah, perfect. It's going to be me and what's his name? God damn it. Tom Riddle. Yeah. He's my debate partner.
That would at least be a more intellectual conversation, and maybe a slightly lower chance of it being a turf conversation.
God. Yeah, fuck Jake. But anyway. Sorry.
That's all right. That's all right. I have a similar sentiment.
Yeah. You're a much more respectable person than I am. Hold on. Thank you for the super chat. Maybe there's a planet of serpentine ETIs who get tempted into sin by a talking humanoid. I want to live on that timeline, and I want to be the humanoid.
I'm actually thinking of a slightly different thing. So I'm imagining the intelligent species as a bunch of slugs, and so the Jesus who has to go there isn't crucified, but he is salted for your sins.
Salted for your sins. Yes. Oh my God. Sorry, this is like kind of on topic, but also a little bit off. The fact, and I grew up in this religion, so trust me, I get it, but also it is still so goddamn wild to me that folks really believe that there is an omnipresent, omniscient, omnibenevolent God that knew everything before the foundations of the earth, and knew that all of this shit would happen, and that like humans were going to sin, and he would need to figure out a way to like reconcile humans to himself. And even though he created all of this and made all of the rules, the only way for this reconciliation to happen, even though he's an all-powerful God, is to have his son, who is also him, come to earth, be crucified, raised from the dead, float up into the sky to go to heaven, which is like, that's not heaven up there, just FYI. That's a totally weird cosmology that doesn't exist. Because that's the only way. That's the only way that you can reconcile the two. And it's like, what is the logic? There's no logic there. I'm sorry.
Yeah. The thing is, we can also do the math on Jesus's ascension, and we can realize, even at light speed, he hasn't really gotten that far in a cosmic sense. He's only 2,000 light years away from the Earth. That doesn't even get him to the center of the Milky Way galaxy.
Jesus is still out there floating.
Yep.
Like, you would think God could speed it along. You know what I mean?
Well, not without paradoxes. If you go faster than light, that's another way of doing backwards time travel, and it causes many
Many
All
problems.
right, there's the divide by zero problem. With special relativity, if you go faster than light, you start multiplying by the imaginary number. It gets that absurd.
You're not the salt of the earth. You know what? S&M kink. That's true. Yeah, y'all can Google it, but it is true. It's my favorite fun fact to tell people that quote C.S. Lewis at me. I'm like, that's fine, but like y'all should know. Anyway, the other thing that I think is really interesting is that like if you look at the creation myths in Genesis, right? Like God doesn't appear to actually know. Like he doesn't appear to have known what was going to happen. He doesn't appear to know what happened. He doesn't know where Eve or Adam is, right? Like he doesn't seem like he knows these things. And so this idea that he is omniscient has been superimposed upon this god of these myths because folks are trying to reconcile all of these different conceptions of God over thousands of years. Like,
Yeah, I mean, really, when I read the stories about Yahweh, I see just a less horny version of Zeus.
very jealous, less horny, you know? But what's up, Ox? Yeah. I will also say this. The Bible has become infinitely more interesting to me since I quit thinking it was this univocal story. Um, and I realized it was 66 books written by different people at different times to try and like honestly just like survive, figure it out. Like, and that's the
Yeah,
thing is like everybody was just trying to figure it out, and so I have so much more like compassion and empathy and sort of almost camaraderie in a lot of sense with the past and the people writing these books because like they were all just trying to figure it out.
yeah,
Like,
yeah.
yeah,
They used a different tool set than what we moderns tend to do, but yeah, they still have like the same worries, the same struggles, the same passions and fears. And when you stop and realize, no, they're just like me. They just have a different way of using their parchment and quill. Once you realize, especially the way that they conceived the world was that they could actually understand it through poetry. That like literally like the sounds of words gave them their power. That's how you can understand how these things come together so much better. Um, the idea of the mechanical universe is still so modern and still so hard to get into our heads.
yeah, yeah. Sorry. Oz is doing a live stream in about 40 minutes reviewing an evangelical who is saying people like us never really believe the gospel. That's okay, Joshua. Rude. I'm trying to figure out how to mod. Correa, can you please give Josh a wrench? Because I am inept. Um, and I forgot what I was saying. Yeah, of course. There's always the people that are like, yeah, you were never a real Christian. Like, okay.
That charge might work better against me because I was very much a cafeteria Catholic is probably the best way to put my upbringing. But on the other hand, I feel like from what I see, especially like the most firebrand evangelicals do with their Bible, I just feel like the best of Christianity, I have performed better with a almost barely Christian background.
Yeah. So did you grow I know you said you were Catholic when or you identified as a Catholic deist in college, but did you
Yeah.
grow up um in a specific religion?
Yeah, yeah. Within Catholicism, like uh, on my mother's side, that was definitely the thing. On my father's side, more or less, though, my father was basically ambivalent to the whole sort of thing. Um, I went to a Catholic school for a good chunk of elementary school time. Went through and did communion, and the way our family treated first communion, we had a party in the same sort of way that Jews might have their bar mitzvah. It felt like that level of importance that we treated it in that sort of way. So it was like a big family event the first time we got to officially eat the cracker and drink the wine in the designated fashion. So had to go through the hoops of doing Sunday school and things like that. But I also remember being extremely bad at paying any attention to religious instruction when I was in private parochial Catholic school. I think the best way to put it was this. I have this memory. Don't remember what the teacher was talking about, but it was during our religious instruction, and I had a white folder and a red pen, and I just started scribbling on the white folder, and by the end of the lesson, my folder was all red and I had an empty pen, and that's all I remember from the lesson. Only later did I find out, oh yeah, that Jesus guy was supposed to be important somehow. How does that work? Oh, now that I'm an atheist, I'm actually paying attention. All I got basically out of my religious instruction is, here's how you put your hand out to receive communion. And Jesus basically, in so many words, said, don't be a dick.
Jesus is a cracker. Okay? That's quite literally what evangelicals believe anyway. Jesus is a cracker. Also, Jesus is a wafer. So, both of those things, whatevs. But there is a section of Baptists that do think Jesus was white. So saying Jesus was a cracker is actually not that far of a stretch. And I'm white, so I can say that, okay? All right. Any other questions? Any other questions, Let's see.
I think I do see the link to the Tang thing that you mentioned earlier. Yeah.
Yes.
All right.
Thank you, Correa. Gave Josh a wrench. Josh, we will not be taking the wrench away. You don't behave. That's true. But you're too nice of a person to do anything that I wouldn't do. So that's fine. Let's see. My religion teacher, did you know the Jews don't believe in Jesus? Yeah, that has to be one of my least favorite fucking things, is how horrible Christians are to Jews.
Yeah,
it makes me want to,
Yeah, at the very least, I am so glad that I have no memories of our priest ever talking about let Jesus' blood be upon them. Reciting that part of the Gospel of Matthew. That all I can ever remember are the better things. And fortunately, that's true as well, because I only learned this maybe a couple years ago. But the priest that I remember having the most was, this older gentleman. I have nothing but kind memories about him. But it was a different priest who baptized me. I only learned a couple years ago from my mother that he was also caught up in the whole boy fondling thing.
Oh, no.
Yeah. So while I was never abused in that way, apparently I was that close to people who did such things. And now I'm here in Boston where, the story really went down.
Yeah, that's a lot. I say this kind of jokingly, kind of not. There's a part of me that wishes I had grown up in a religion where I had to confess my sins. Because I am very chaotic, and I've always been very chaotic. And when I was a Christian and I was silently confessing my sins to Jesus, right, and racking my brain for things I had actually done wrong, had it been somebody like a priest, I would have just made some shit up, some wild shit. I know I would have done that. I would have done that. Because I can't help myself from just pulling the pin and throwing a grenade. But in any event, yeah. Yeah. All right.
I don't know if I ever actually did confession. Not that I remember. And it's not because I was a perfect little boy. Again, if my mother were here, I'm pretty sure she could give some examples of me failing to be that way. But in fact, actually, my dad called me earlier. I'm going to have to call him back after this.
To tell you that you weren't a perfect little boy?
He doesn't have to remind me. I remember of the memories of things I remember being less than good about, first Christmas that we got a new VCR, my thought was, oh, there's this flap here. I should put things in it. And so what do? I take all the styrofoam it came with and just started stuffing it in there.
Oh, that's nice.
Yeah, I almost destroyed the brand new VCR that my dad had just got for Christmas. And of course, I say a VCR, and everyone's like, "What that ancient technology?" Well, back then that was probably a couple $100. So
yeah, no, I recall.
Yeah,
Yeah.
Yeah.
I mean, when
I was a
young
stupid
child,
kid, just like everyone else.
No, I mean, when I was a young child, uh, some of you have heard this story. When I was about 5 or 6, I lived in like a court in a cul-de-sac, and there was this family that lived next to me, and they had a son who was a little bit older than me. I don't remember exactly how much, but a couple of years. And I believe his name was Justin. And I sometimes was forced to like his mom would ask like, "Oh, does Jessica want to come over and like do whatever?" And like I didn't. But I would get sent over there for like to be polite, you know? And this one time I was over there and the mom like wasn't home, and this fucking kid was like showing me his junk, you know? Which I was like not about. So I like ran back to my house. And I was like, direct action, baby. Like I've always been a communist. So I went I got some
Please don't tell me you took a sickle, okay?
No sickle. I got some
Okay.
Febreze. And we had these like, I don't know, these rocks sort of in front of our house. And I was a small child, so they weren't huge, but they were big enough for me to kind of like hide behind. And so I went with my Febreze and I like hid behind this rock, and he came out looking for me. And when he got to like the rock where I was hiding, I just popped up and Febrezed him directly in the face. Like eyes and all, you know what I mean? I got the shit beat out of me by my parents. However, he never fucking did that again. So, so you know, I've always been this way, if anyone's wondering.
Oh, I'm now just remembering why I asked my parents for examples of me doing bad. I'm sure my brother could also give some memories. Younger brother, and I had to do a lot of growing up to be a better older brother.
So wait, do you have an older and a younger brother?
No, I have a younger brother and only a younger brother, but I had to grow up to become a good older brother.
Yeah.
I was... Yeah, there are a few things I'm pretty sure I did less than I can be proud of back then. But maybe let's not put them all on the live stream tonight.
I have 4 little sisters. I've done a variety of just terrible things, but they're funny. And my sisters and I talk about them all the time, so it's fine. However, I was the big sister that was like, violence is the answer. It's the answer. Sorry. You know, I'm the oldest of 5 girls, and I had very dysfunctional parents. So like I was the dad. Right? I'm the mom, the dad, and the oldest sister. So like when each of my younger sisters, when they start dating someone or bring someone home, like they're not concerned about my dad. They're like, you have to meet my older sister. Like, best of luck. If you can get through her, then like you're good to go. My dad's just happy to have like another man in the home.
You are now just making me wonder about one bit of history with my family that I don't know. Because, you know, my mother has only ever said good things about her siblings. But I have to wonder what kind of possible violent events may have happened in there. And she comes from a big family. My mother is the middle child of 11.
Jeez.
So that's the most Catholic part of our family, Catholic size. But yeah, with that many kids running around, nefarious things are going to happen between them. I think that's a given.
I just feel like that's like, if you're an older sibling, you have to do some shit. And if you're a younger sibling, you're also going to do some shit. It's going to be different shit, you know? But also like as a younger sibling, you're going to have a lot more freedom, and also probably like stability than the older children did, which is like very true in my case. So it's a trade-off, right? And now we have funny stories, but we're all super close. So, you know, it worked out. It worked out.
We all made it.
Come meet my sister. Give her 5 more minutes. She's lifting. Yeah, that's true. That is true. Only one of my the sister that is right after me, she's married. And before she got married, she came to me and was like, I need to know if you really actually approve of him. And he's awesome. So I did, like, absolutely. But it is funny because, like, yeah, it's just funny. But anyway. Okay.
I think unless there's any more questions, we should probably wrap up because otherwise we're going to get too much into personal story time.
Yeah, seriously. All right. If there's any more questions, I'll give you like the next 60 seconds. Put them in the chat. If not, we're going to wrap up because this could just turn into like story time. Which I need Aaron to go talk to his parents so he can get the stories, and then we will come back, circle back. You know what I mean? To like, yeah. I did make my sister, like, we played house, and I didn't want her to play with us, and by us I mean me and my friend, and so my mom would make us, and so I made her be the cat, and her name was Poop because I was very mature. You know what I mean? I was a very mature child. All right. We're going to do going, going, gone. So like 20 more seconds. If you don't have a question, then we'll wrap it up.
All right.
19. 18.
I'm actually a little surprised my cat decided not to pop up and make himself known.
My 3 dogs are sleeping right there on my bed. Yeah. All right. I don't think there is any more questions. Doesn't look like it. Every sperm is sacred. Well,
every sperm is grand.
Sacred. Agree. Thanks, Aaron. Looking forward to your talk. And Baglows.
Okay, so give a little bit of background. Sohan and I are friends. We're both associated with MIT.
Oh, wait. And, this is the person you tagged instead of me.
Yes.
Hi.
Since your handle started SOH, Sohan popped up and I didn't carefully there. But I'm doing a talk at MIT in a little less than a month, and Baglow is another Catholic theologian who's also like saying, Catholic theology and aliens, totally compatible, no problems at all. And I guess I have to go and make a stink because it's what I do.
I mean, that seems very weird to me that there would be no problems with Catholic theology and aliens, but I'm interested to hear what he has to say because that seems wrong.
Well, like I mentioned, like with the case with Giordano Bruno, is they basically have to be ignorant about the facts or straight up lie about it. And that I've literally seen in the literature where they say, hey, here's what the historian is saying, but instead I'm going to cite the 1908 Catholic Encyclopedia and say that that's more authoritative about what this historian said. So therefore, no problems at all, la-di-da-di-da. I have a hard time taking you seriously anymore. I have that in the footnotes of our book. So all the details will be there. When it comes out, everyone buy at least 10 copies.
Yeah, there's no problems. All you got to do is lie. Again, I too can make random shit up. I mean, that seems to be the way, of religion. When in doubt, just lie.
Fake it till you make it.
Fake it till other people believe you. So the talk that you're giving, I'm assuming there's not a digital feed. You just have to be there in person.
That is a good question. I think they're going to try to also do a digital feed as well, because I think they also have a YouTube platform if they're going to live stream it or record it and then show it later. I'm not 100% sure on that. I know a guy who I can ask, though.
All right, cool. Well, oh, wait. Sohan says it will be live streamed.
That's the guy I was going to talk to.
Okay.
Almost certainly via YouTube, because I know they have a YouTube channel. They might also have a Facebook group.
Okay. Wait, he says he will post the link in a week or so, but where? Sorry. I don't know where to look.
Wherever it's posted, I will find it, and I will also put it on my own social medias. So it should not remain hidden.
Yeah, and your Twitter handle is Adair Aaron?
Let me triple check because, again, sometimes I have the memory of a dead goldfish. Adair_Aaron.
I was close. Secular Society of MIT on YouTube. Look it up. Love the stream. Thank you for killing my Sunday, Monday, dread face, red heart shape. You're so welcome. I feel like a scene girl from like 2000. Okay. This has been super fun. thank you for being here. Thank you for giving me 2.5+ hours of your time. This has been delightful. I've learned so much, and I have enjoyed all of you in the chat. If you haven't, go find Aaron on Twitter, Adair_Aaron. When he gives me his YouTube, I will post it. Secular Society of MIT, again, on YouTube. Is your book pre-orderable anywhere?
Not yet. In particular, the person who's been putting that together has been my co-author, Johnny Pierce. And because we're still... whatever shenanigans is why we haven't done it yet.
That's fine. I still have to figure out how I'm going to endorse it. But I do endorse it. 12 out of 10, no notes. All right, y'all. If you haven't already liked and subscribed, please do. Thank you for being here. You can find me on all the socials, but y'all already know that. And until next time, stay chaotic.
Oh, shit. You done fucked up, man. Ain't nothing but a gangsta party. Y'all in deep doo-doo.